Good morning, everybody. It's morning. It's like a real job. This is like a regular job. This episode of the Joe Rogan Experience is brought to you by NatureBox. NatureBox is a way that you can get delicious, healthy snacks delivered to your home or your office. I have them delivered to my house, but they're the official snack of the Joe Rogan Experience now. Official. Really yummy stuff, and you can get it as good for you as you like, meaning, you could order pretzels, or if you want to, you can go gluten-free, low sugar. They have zero trans fats, zero high fructose corn syrup, nothing artificial, and they're great. They taste delicious. There's ones that you guys will never see. There's these sriracha cashews. They're not getting in here. They never make it. They get to my house. I open the box. I pop it open. I said, "Where are the fucking cashews?" Oh, give me them bitches. I'm never bringing them in here. I'll just tell you right now, Jamie, you're never getting in them sriracha cashews unless they send like a triple order. They're too good. They're my favorite new snack. But NatureBox has free shipping anywhere in the U.S., and it's just an awesome alternative to vending machine snacks. If you're at work and you're looking for snacks all the time and you hit that vending machine, you're like, what can I eat here that doesn't make me feel like a piece of shit? Usually the answer is nothing. Maybe you might go with potato chips over candy bars or fucking cookies or something stupid. But you could eat fairly clean. You could get really clean where you could have they have these spicy pistachios that are delicious. Or like I said, you can go with pretzels. But I recommend the sriracha cashews.
They're there.
Oh, they're so good. They're so good, dude. Trust me. It would be your favorite thing if I ever brought them in. They're never making it in here, son. But NatureBox just allows you to eat healthy and have it delivered to you, and cut out all the nonsense of that terrible feeling that you get when you eat crappy food and just get angry at yourself. But they have South Pacific plantain chips are another one. Fantastic. They're never making it in here. They get devoured. But go to naturebox.com/Rogan and save 50% off your first box. That's naturebox.com/Rogan. naturebox.com/Rogan. Enjoy it. I enjoy it. And like I said, they're the official snack food of the Joe Rogan Experience. What'd you say?
Enjoy it.
Enjoy it. Brody Stevens. Enjoy it. We're also brought to you by Onnit.com. That is ONNIT. Onnit is a human optimization website. We sell you the tools that you can use to optimize your health, your life, your fitness. We sell things like strength and conditioning equipment, like kettlebells and battle ropes and mace balls and all these things that we use for steel maces, all these things that we use for strength and conditioning workouts, as well as healthy foods like hemp force protein powder, earth-grown nutrients, which is an excellent supplement to your average diet, the average healthy diet. Most folks, the reality is, you don't quite get enough nutrients, you don't quite get enough healthy protein, you don't quite get enough good foods in your diet. Most of us are too busy. Most of us have jobs. Most of us work. Well, there's certain ways that you can add to your diet where you can give yourself the building blocks, give yourself the tools, the healthy nutrients that your body needs, like earth-grown nutrients. And earth-grown nutrients is an awesome new supplement that we have that's a combination of a bunch of different things. An antioxidant blend that is all food-based, based on things like Peruvian purple corn, acai fruit, grape skin, a ton of different ingredients. And it has a jaw-dropping 75,000 ORAC score. The ORAC score is the antioxidant score. All of it is explained on Onnit far better than I'll be able to explain it to you. It also has a power green blend with spirulina, alfalfa, oatgrass, kale, barley, wheatgrass. All these different things, you can add it to a smoothie. You can add it to just a glass of water and drink it. And what it does is it gives you a little cushioning. It gives you just sort of a nice supplement to cover the distance between what most folks eat and what really your body actually needs and deserves. And what Onnit is designed for, and what our goals are, is to give you everything that you need to optimize your health and your fitness, and just to sort of bridge the gap between what the average person takes in their life and has in their body and what you really could actually use and need. And when it comes to the strength and conditioning equipment, we just buy the best shit we can possibly find, whether it's ab wheels or medicine balls or kettlebells. We try to find the highest quality stuff. We try to find the stuff that we find that is the most beneficial for strength and fitness. And then we sell it to you at the most reasonable rates that we can. If you use the code word Rogan, you will save 10% off any and all supplements at Onnit. That's ONNIT, and use the code word Rogan. All right, Randall Carlson is here. It's early in the morning. Why fuck around, Jamie? Cue the music.
Joe Rogan Podcast, check it out.
The Joe Rogan Experience.
Train by day, Joe Rogan Podcast by night, all day.
Trying to get the old brain fired up in the AM. It's very unusual that, well, I usually get up around this time, so do a podcast around this time. Randall Carlson, ladies and gentlemen. I first met Randall quite a few years back in Atlanta. He blew my brain open with a bunch of crazy talk about asteroids and just all kinds of crazy shit. Sacred geometry, and you're a very interesting cat, and you got a lot of cool stuff to talk about. So I'm glad we finally got you here on the podcast. You're a much requested guest on my online forum. So folks know about you. They know about your work. And you're here.
Uh-oh. All these years of anonymity, and now I'm suddenly, I don't know if I'm ready for this, Joe.
I think you're ready, dude. I feel it from you. This is your time to shine.
All right, Joe. Coming from you, that's all it requires.
Well, we had a great conversation when we first met. And
we did.
Ever since then, I've been trying to figure out a way to repeat it online. There's videos of us actually having parts of the conversation, but there's music in the background. We're at the comedy club in
Crazy
Atlanta.
Shit going on,
Yeah. So you first, I don't remember what we first started talking about, but you blew my mind when you started talking to me about the Holocene crater, and that this pretty distinct evidence that, there's been more than one event on this Earth besides the one that everybody knows about, the 65 million year ago one where the big chunk of rock hit the Yucatan and killed the dinosaurs. But there's been a series of those, and that these things may very well be responsible for a lot of the cataclysmic stories that are in Epic of Gilgamesh, the Noah's Ark story. All these different fables and tales of ancient traditions may be based on these cataclysmic disasters. And now, since we've spoken, science has started to validate a lot of your theories and ideas even more substantially. The discovery of this nuclear glass that they find all throughout Europe and Asia. Tell me about all this stuff.
Well, did you catch the thing about a month ago? I think it was in the New York Times, most of the major newspapers, a group of former NASA astronauts and scientists came out, said new evidence was showing that we're probably somewhere between 3 and 10 times more likely to encounter things than anybody had previously been estimating, even 5 to 10 years ago. Yeah, it was a pretty major article in most of the mainstream media.
You mean by encounter things by getting hit by something?
Yes. Of course, you remember what happened on February 15th of 2013, right? What happened on February 15th?
Was that the Russian?
Yeah. And what was really interesting about that is because everybody was, at least people who are interested in this sort of thing, were kind of looking to the sky anyway, because this was the closest pass of an asteroid coming within 17,000 miles of the Earth. At the same time, this object totally out of the blue came in and exploded over Chelyabinsk, Siberia. So it was very interesting and coincidental, if there are such things as coincidences, that here, when we're expecting this very close flyby of an asteroid, a near-Earth asteroid, coming actually within our geosynchronous satellites, within the orbits of those satellites,
wow,
At the same time that this object is coming within 17,000 miles of the Earth, suddenly, unexpectedly, here comes this second object and explodes with the force of about I believe it was about a 50 kiloton nuclear weapon. And of course, it had exploded quite high, about 20, I believe 18 to 20 miles in the atmosphere. And so it didn't kill anybody. However, the thing to bear in mind is if that object had been just a little bit bigger, or it had been a little bit denser, or the angle of approach had been a little steeper, instead of 1,600 injuries, there probably could have been 1,600 or more casualties. At that point, I think the world would have really sat up and taken notice. But it was basically just a warning shot.
It seems to me that our knowledge of asteroids and meteor impacts and things of that nature, our actual experience on it is based on this short window that we call human history,
Yes.
which is, for the Earth, such a brief, tiny blink of an eye.
It is. Although I like to point out there that, when you say human history, we're talking, 4,500 to 5,000 years ago. Generally, I think most historians of ancient history will usually say that the emergence of cuneiform writing in the Middle East marks the beginning of official recorded history. But you got to bear in mind that we modern humans have been around a lot longer than that. Right now, as far as the hard evidence goes, which is what I like to refer to, which means skeletal remains of humans that, as far as we know, are basically no different than modern humans. If you put flesh on them and dressed them up in modern clothes and they walked down the street, you wouldn't think they were anything unusual. Modern skeletal remains of modern humans are now dating between 150 and 180,000 years. So when you think about that, compared to what we actually have of our record of history, our record of history is 1/20th, 1/25th, 1/30th of the actual time that we humans have been here. Now it could be that modern humans have actually been here much longer than 180,000 years. We have no way of knowing at what point we moderns first appeared on this planet. But when you think of 180,000 years compared to, let's say, in round numbers, 5,000 years, it means that there's a lot of the human story missing. And the thing that's always intrigued me is that, given the assumption that they would have had the same intelligence as us, they've got the same brain case size, the same cranial capacity, so one would assume that with brains as big as our modern brains, they were able to think, they had forethought, they were able to plan ahead, presumably have have some kind of a tradition that could be passed on from generation to generation, and accumulated learning. But what we see is that there's basically no record to speak of what people were doing culturally. And that has led a lot of scientists to assume that for all those tens of thousands of years and hundreds of generations, that people were essentially living nothing more than a subsistence, kind of hunter-gatherer existence, right? But what they haven't taken into account is the extremity of some of the global changes that have occurred in the interval that we humans have been here. And as we go through our discussion today, and we'll pull up some images, I think you'll begin to get an idea of how extreme and how sweeping some of these changes have been, and why in the aftermath of those changes we shouldn't expect to find a whole lot of hard cultural evidence. Because what you'll hopefully begin to appreciate is that were some of these events of the scale and magnitude that have happened probably a dozen or more times in the 150 or 200,000 years that we've been here, were those events to occur today, 10,000 years from now, archaeologists would be sifting through the rubble looking for any kind of evidence that we had ever been here. And that's the thing we have to get into our consciousness. And I guess if there's any implication to the work that I've been doing is that we certainly can't take our present position for granted.
It seems very difficult for us to put into perspective numbers like 10,000 or 100,000 or 1,000,000. We know that the universe has been around allegedly for 14 billion.
Yeah.
So the Earth is 4.6 billion. Those numbers are so weird to us. They don't register. They're just like, I know 4 billion is more than 400,000, but both of them are alien. You know what I mean? It's like, I don't think we could really wrap our head around the idea that 10,000 years is such an incredible length of time that if you left a car out for 10,000 years, within 3 or 4,000, it would be absorbed completely by the Earth.
Joe, within 3 or 4 centuries.
Really?
Oh, yeah. I mean, if you look at, steel-body cars, I remember very well as a kid, not far from where we lived, there was a auto graveyard. And all the teenagers around there who were racing cars back in the 50s and crashing them up and everything, they seemed to end up there. And as a kid, I used to like to go and kind of hang around there and play in some of the old cars. But they were already, after sitting out there for 10 years, already well on their way to rusting away. Once that process of oxidation begins to take place, it accelerates. Mm-hmm. Not far from where I live in Atlanta, there was an old iron bridge that had been built around the 1890s. And it's no longer there, but by the 1980s, it had almost rusted to nothing. Within a century, it almost rusted to nothing. Metal does not last long when exposed to the elements. There was an interesting series of shows a few years ago. I think it had to do with the idea of what if humans just suddenly departed? Mm-hmm. What if we took humans out of the equation? What would happen to all of the infrastructure left behind? Just under normal kind of gradualistic change that we're used to within the last few centuries. The upshot of it is that 10,000 years from now, it's pretty much gone. If you look at the great buildings that make up all the metropolitan areas now of the world, most of them are steel frame structures, and they're clothed in a skin that will keep the elements out maybe for a half a century. But without maintenance, that the Golden Gate Bridge up in San Francisco is constantly undergoing maintenance, because if you stop maintaining it, immediately it starts decaying. Immediately it starts rusting. And interesting, if you think about if humans left the planet 10,000 years from now, some interstellar anthropologists arrive, what would they see that would indicate that we had been here? What do you think would still be left after 10,000 years? There's actually 2 things that they named in this particular program. I bet you can guess one of them.
Mount Rushmore?
Mount Rushmore. Good guess. Yes, that's one of them. And, of course, the Great Pyramid would be the other one. And that's it. Everything else is gone.
Wow.
Now, when you now begin to factor in the thing that I've been basically working with is the idea that we have these intermittent, I call them nonlinearities, discontinuities within the normal orderly progression of things, the catastrophes, if you will. Superimpose a few of those in the process, and basically 5,000, 10,000 years from now, you're not going to find much to show that we had been here.
That's incredible. And when you see structures like Göbekli Tepe, which is within the last couple decades been unearthed in Turkey, which has really thrown a giant monkey wrench into the timeline of the hunter-gatherer transition into the modern agricultural city. We're in a weird state because people are starting to dig up these things, and Göbekli Tepe was a completely unknown structure until this one farmer or herder had found a stone and started unearthing it, and then realized it was these huge stone pillars of an unknown civilization carved with 3-dimensional shapes of these animals. Some of them aren't even native to the area, so it's incredibly confusing and purposely covered up 12 to 14,000 years ago, which means that who knows how long it was there before. It could have been several thousand years old when they decided to cover it up, but it was purposely filled in, an enormous area, purposely filled in somewhere around 12,000 years ago.
Could it have been purposely covered up in order to protect it and preserve it?
Could be, right? That we were hoping, or they were hoping rather, that someone like us would come along. Not us, like definitely not me. Maybe you. but someone would come along and uncover it and then go, whoa, what's this all about? Like maybe they knew that there were going to be moments in time where these things happen, these impacts, these asteroidal impacts, and that there needed to be some sort of a way of keeping track or some sort of a way of preserving.
Well, that would probably be one way of preserving it for sure. And the other thing would be, it's just like you mentioned the two things, Mount Rushmore and the Great Pyramid, of course, are both built of stone, which is obviously much more durable than steel or the fabricated materials that we're making today. Even plastics are going to degrade over a few millennium. But if you want to preserve something for millennia, make it out of stone and make it monumental. And we're looking at something like you just made an interesting point about it could have how much previous to the burial had it actually been there. And it's difficult to date stone. The way you would date stone is you can use various cosmogenic ways where when you expose stone to atmosphere, it's going to accumulate cosmic rays, which cause changes within the stone that can actually be measured. But if it's buried, it's not going to be subject to cosmic rays, so that you can't date it that way. What you'd probably have to do is find some organic material within the soil matrix or matrix of material around it and date that material. But even there, that's not going to tell, that's only going to give you a minimum date. So in other words, the structure is there for who knows how long. They decide to bury it, and they bring in the material and bury it. And if some organic material is in that soil, it's not necessarily going to be indicative of the age of the stone structure itself. It's going to be indicative of the time at which it was buried.
And how did they determine that it was buried at 12,000 years ago? Was it the uniformity of the depth of...
I would assume. Now, I haven't made a study of Göbekli Tepe yet. I'm hoping that when I get a chance to hang out with Graham Hancock, I'm going to get filled in on all the details of that. I don't know specifically about that. Other, monuments, I do suspect that, Gunung Padang is probably very old. It's in Indonesia. A lot of the monumental stonework that we find, like at Baalbek, where you have these monstrous megaliths, probably go back to Pleistocene times. And when I say Pleistocene, I'm talking about the period from like 10,000 years back to about 2.5 million years ago. The time during which there has been this succession of glacial ages and interglacial ages. You mentioned the term Holocene. We talked about that. Holocene is essentially the modern geological epoch. We've been in this Holocene epoch for generally, they say 10,000 years in rough numbers, although it's becoming much more precisely dated. Now you'll find a lot of references in the scientific literature that gives the date 11.6 or 11,600 years as being the onset of the Holocene, which is an interesting date for me because I don't know if you've ever read Plato and his accounts of Atlantis. There's two of his dialogues, Critias and Timaeus, in which he describes Atlantis. And he gives the dating in there at least on 3 separate occasions. And he always places it, there's this whole success, the whole lineage of the story goes back to Solon, who was a historical character, an authenticated historical character who lived at about 600 BC. And he was a lawgiver and poet in Athens, and due to political pressures and stuff, he went into a 10-year exile. And during that 10-year exile, he went to Egypt. And it was there that he presumably heard the tale of Atlantis from elderly Egyptian priests. And he was told and came back and then told the story to his grandson, who told it again to several individuals before it actually got to Socrates and then Plato, who presumably wrote it down. But what it's interesting is that in Plato's account, he gives the dating for the demise of Atlantis as 9,000 years prior to Solon's exile to Egypt. Well, given that took place in, give or take a decade or two, 600 BC, we go back, that's 2,600 years ago, okay, add that to the 9,000 years, and we've got 11,600 years ago. Now, according to Plato's account, he says that it was shortly after this great war between the Atlanteans and the Proto-Athenians that there was this tremendous cataclysm and Atlantis sunk beneath the waves. So he's giving that date at 11,600 years ago. We now know from the scientific record that at 11,600 years ago, there was a major climate transition, and there was a catastrophic warming spike that was associated with a mega-scale meltdown event of the great ice sheets that were covering North America. It was this event at 11,600 that essentially jerked the planet out of the depths of this ice age that it had been in for thousands and thousands of years. With that melting, you had a rapid rise of sea level. So it's very interesting that the date that he gives is precisely now the date that that the scientists are giving for this transition from what's called the Younger Dryas. I think Graham has mentioned that in some of your interviews with him, the Younger Dryas, which was this climate spasm that ended the last ice age. So if we look at the chronology of events, around 26,000 years ago, we were in the latter phases of what appears to have been an interglacial period, not too much different from what we're in now. Around 26,000 years ago, the climate rapidly degenerated, and these massive glaciers had expanded during this, what they call the final phase, or the late Wisconsin, they refer to it, because initially they were looking for this evidence in the state of Wisconsin, so they named this last final phase the late Wisconsin. So around 26,000 years ago, we see the launching of this final phase of the ice age, the late Wisconsin. Then at around 13,000 years ago, as the dates are now giving it, there was this enormous spasm of warming. And this seemed to be associated with rapid melting and the first real rapid sea level rise. Okay? What happened is after a very short interval of time, the climate snapped back into the full depths of glacial cold. Now, what had happened was, if you go back 18,000 years ago, this was the coldest part of the ice age. I mean, this was bitterly cold period of time. Where I live in Georgia, was the forests that grew there were like the forests you find in Canada now. You had tundra up in northern Kentucky and southern Idaho, tundra in southern Ohio, excuse me. So it was a really, really different climate. And once you got to northern Ohio and the northern United States, where New York City is, Chicago, the Great Lakes, the Dakotas, all of that was under this massive ice sheet, thousands of feet thick. When you go up into Canada, over Canada, the ice sheet was up to 2 miles thick. I mean, think about that, 2 miles thick of ice. And it reached from the Atlantic to the Pacific Ocean and from the northern United States as far south as the 45th parallel all the way up to the Arctic Circle. Now, that is a drastically different world. Bear in mind, too, that with that much ice piled up on the surface of the land, sea levels, which contributed the water that formed that ice, had to go down. And it's now well documented that sea levels during the depth of the ice age were at least 400 feet lower than now, which means that the continental shelves of the planet were basically exposed now. Where I live in Georgia, if you go out and stand right now on the beach, like at Cumberland Island, which is a beautiful wilderness preserve, you stand there on the beach. If you were suddenly transported back to the depths of the ice age, you'd be in the middle of a boreal forest, meaning a northern forest with spruce trees, larch trees, alder trees, the kind of trees you find now in the northern United States, Canada, that area. And the beach wouldn't have been anywhere close. It would have been another 50, 75, 100 miles further to the east.
Wow.
Because as the sea level drops, what happens? It recedes, right? And so when this final phase of the ice age came on, sea levels began to drop. And so what it did was it exposed all of the shallow marine ecologies that rimmed all of the continents to the atmosphere and basically would have caused enormous ecological havoc. Well, then within a millennia or so, the forests had expanded and had now grown out. So now off the eastern seaboard of the United States, they constantly will find the remains of tree stumps and forests that had been growing there 14, 15, 16,000 years ago. Now, the ice begins to melt, sea level begins to rise. Now, it's important to realize that if we look at the way modern civilization has evolved, what do we see is where do the first cities show up? Aren't they mostly trading cities that show up? They're port cities. They show up along the confluence of rivers. They show up where rivers meet the oceans. They show up on the coastlines. Okay, so if you had major cities during the Ice Age, and as Graham has pointed out, they're now 400 feet underwater.
Wow.
So you begin to appreciate, when you begin to really look at the history of our planet, what you realize is that it's been just almost unimaginably dynamic. An alteration from a interglacial to a glacial age is an extreme process. And so I guess the upshot of it is that, when we look now at the climate record that we have in hand now, which has been pretty much reconstructed with a fair amount of accuracy back to about 400,000 years. And these are primarily based on ice cores extracted from Greenland, extracted from Antarctica, extracted from mountain glaciers, and mostly Antarctica and Greenland, though. When you pull out that ice core, it's layered. You think of cutting down a tree and looking at the annual layers, where you can actually count the number of layers in a cross section of a tree log, and you'll know how old it is, right? Mm-hmm. Well, it's very similar in an ice core. You've got layers, annual layers, because each year there's snow that falls. It gets compressed into firn, F-I-R-N, which is the transitional phase between snow and glacial ice, and it eventually gets compressed into glacial ice. And when you look at a cross-section of the ice core, you'll see these fine layers in there, right? So they can go back and they can look at these layers, they can count the layers, and there's a lot of things going on in these layers. Oxygen isotopes are a critical one for ascertaining climate changes, because oxygen isotopes are a function of temperature. And we have a graph here we'll pull up in a minute. We can actually look at that. But what we see is that the climate has constantly oscillated back and forth. And when we look at the Holocene, going back 10,000 years, and then we take that comparatively and we go back 250 to 400,000 years, we can now begin to reconstruct these intervals of glacial periods, interglacial. And here's the thing that should be sobering to everybody on the planet today as we think about climate change and all of this, because obviously it's constantly in the news and all. The longest interglacial period now on record for at least the last 250,000 years, the longest one, the longest unbroken period of interglacial warmth is the Holocene, the one we're in now. Whoa. We've already exceeded by several millennia the longest previous period of interglacial warmth. I don't hear him talking about that. I don't hear Al Gore talking about that. I don't hear anybody talking about that in mainstream media, but it's hard scientific fact.
Yeah, we would be shitting our pants way more if it was a global cooling than if it was a global warming.
Let me tell you, we're going to pull up another graph. We'll pull up a graph in a minute which shows you that even within the last couple of thousand years, periods of global cooling have not been pleasant times. Periods of global warming is when we see human population expanding, when we see cultural advancement, when we see lifespans increasing, when we see infant mortality decreasing. Periods of global cooling are when we see populations going into decline, when we see lifespans diminishing. We had a period of global cooling that began between 536 and 540 AD. It was this period of global cooling that launched what we know as the Dark Ages. And this has now been well documented by dendrochronologists. Mike Bailey is one of the leaders of this, who's been looking at the climate changes of the last couple thousand years as preserved in the tree ring record. Between 536 and about 544 AD, we find that forest growth in the northern hemisphere almost came to a stop. And one of the consequences of that was it was associated with a global cooling. And for multiple years running, there were agricultural collapses where, because of the cold and the damp that came on with this, the historical record is interesting because you read some of these accounts that were preserved from that period. They talk about weeks at a time where they couldn't see the sun. They talk about when it did show up, it was just a feeble imitation of itself. They talk about, years with no summer, basically. So what you had was succession of crop failures that led to people becoming malnourished. Once they became malnourished, their immune systems became weakened. And in 542 AD, about 6 years after this well-documented transition occurred, we had the onset of the Justinian plague, which wiped out a third the population of Europe. And it took 300 years to recover from that.
Wow.
And we didn't recover from it until the climate shifted again, and we went into what's known as the medieval warm period. And the medieval warm period was the time when the Scandinavians were farming on the west coast of Greenland, where now it's perennially frozen. And for about the next couple of hundred years, the climate was, according to some researchers and some scientists, as much as 2 degrees warmer than now. And you think it had to have been warmer if they were farming in Greenland, where it is now frozen ground. It had to have been warmer. And one of the things that happened was with this warming, you had an expansion of the growing season. And you also had the latitude belt at which viable farming or agriculture could be practiced shifted 300 to 400 miles north of where it had been, which meant that for the first time, England actually had a flourishing wine industry, which didn't exist previously, and it has only existed until recent times because of genetically modified crops, is now allowing them to grow grapes where they haven't been able to grow wine grapes until we go back to the medieval warm period. So what happened was now there was a lot of food for people to eat, right? People got healthier. Human population began to increase, right? We began to accumulate wealth. We began to carry on commerce and trade. After this 300 years of dark ages where learning receded into the monasteries and life was very unpleasant, very short, very brutal, very unpleasant. Now we had this warming period, okay? With the expansion of agriculture and the abundant food supply and the prolific harvests, people were getting strong, healthy again. Stature, and it's been well documented that during this 200 or 300 years of the medieval warming period, human stature actually increased by inches, average human size, okay? By 1150, this accumulated wealth that had ensued from the benign climate of the medieval warm period is what allowed the great cathedral building era to ensue, which began between 1130 and 1150 AD. And what we see is these magnificent cathedrals. If you've been to Europe and visited any of the cathedrals, put that on your to-do list.
Yeah.
Get there and look at some of these extraordinary works of art that were built during the High Gothic or High Middle Ages between, like I said, about 1150 and the early 1300s. They built about 80 of these gigantic, magnificent cathedrals that required the organizing of thousands of highly skilled craftsmen, armies of workers and craftsmen. You had stonemasons and carpenters and glaziers and astronomers and geometricians and all of these people brought together to create these incredible cathedrals. And it was made possible by the fact that European society had become relatively wealthy. And this wealth was brought on by this global warmth, right? Now what we see, go ahead to the end of this magnificent Gothic building boom. And by the way, there's about 500 smaller abbeys that were constructed during this interval. This was a very prolific time for a number of reasons. This was the time that you had the Templar Knights forming. You've probably heard of the Templar Knights, I'm sure. You had schools of Kabbalah being founded in Spain, and you had the rise of Catharism. You had the troubadours. You had these amazing spiritual things going on. Amazing. Culturally, it was a very extraordinary time, those High Middle Ages. Well, a lot of those Gothic cathedrals were never finished. And what we see is that some of them have the appearance, I'm a builder by profession, and I've looked at some of these, and what it's very much like is they're going along building, and then all of a sudden one day nobody shows up to work. And there's still tools laying around. There's still materials that are off in a pile that were waiting to be incorporated into the structure. And what happened was that the climate began to cool again between 1315 and 1320, precisely when we see the end of this tremendous Gothic building boom is when the climate began to cool. And it cooled for the next several decades. And what we then see is a repeat of what happened between 536 and 542 AD. Agricultural collapses, crops rotting in the fields, people going hungry. I think it was around between 1340 and 1345, the onset of the Black Plague. And once again, the population of Europe was decimated. And it took 150 years basically to recover from that. And what we see is that what was happening is the planet was shifting into what's called the Little Ice Age. You probably heard that term, the Little Ice Age, right? There was two phases to the Little Ice Age. And the first phase began, like I said, around 1320, lasted about 150 years, and then there was a break. And it was during that break, that warm period, that basically the Renaissance kicked in, and we began to really move forward. The second phase of the Little Ice Age came in during the 1600s, and it was actually even colder than the first phase. And worldwide, glaciers expanded to the largest they had been in 10,000 to 12,000 years, since the end of the Big Ice Age. Throughout the whole Holocene, glaciers had been smaller. Now, during the Little Ice Age, they grew. And they grew to the biggest that they've been in 10,000 years. It's important to have that context of understanding when we talk about glacier recession, because the glaciers begin to recede around the middle of the 19th century worldwide as the Little Ice Age began to wane and global warmth began to return to the planet. This happened in the mid-1800s. Around 1840 to 1860, we see the Little Ice Age coming to an end. And at that point, the glaciers worldwide began to recede. They began to contract. They've been pretty much contracting uniformly since then. So when we're talking about glacier recession, it's important to understand that the glacier recession really began a century and a half ago or more and has basically continued more or less uniformly since then, with no real change with the advent of human fossil fuel to the atmosphere, human carbon dioxide, which began really in earnest during the Second World War, is when we began to add significant amounts of carbon dioxide to the atmosphere. It's important to realize that the glaciers had been receding almost a full century before that point.
So when you see all this modern hysteria about global warming and the human-created global warming that we keep hearing about in the news and that our influence on the atmosphere, does it drive you crazy? I mean, do you think it's silly? I mean, obviously, human beings are contributing to the carbon footprint, right?
Obviously, yes.
Obviously.
Yes.
And obviously that has an effect on global warming.
Yes.
Yes.
Now, but you got to bear in mind that carbon dioxide is only one variable in a very complex equation, right? There are many factors influencing climate, of which carbon dioxide is only one. My problem with so much of the stuff that's coming out in mainstream media, which is coming through the Intergovernmental Panel on Climate Change, is simply that when they were instituted back in the early 90s by the United Nations Framework Convention on Climate Change basically gave them a mandate, which is demonstrate that humans are causing climate change, right? So they focused exclusively on carbon dioxide, but there's all kinds of other things going on. For example, cosmic rays are constantly bombarding the Earth, right? Cosmic rays produce clouds. The more the cosmic rays penetrate the atmosphere, the more low-altitude cloud cover there is. Low-altitude clouds reflect heat back into space. Now, the amount of cosmic rays penetrating the atmosphere is a function of a couple of things. You've got the heliosphere, which is the whole, essentially the energy envelope of the sun, which encompasses the whole solar system. The sun actually is fairly variable. And what that means is that when the solar wind is in a more intense phase, like when the sunspots, for example, are very active, the solar wind is much stronger. What that does is it serves as a buffer that prevents cosmic rays from penetrating the atmosphere of the Earth as strongly as they did previously. Also, the geomagnetic field of the Earth acts as a buffer. So here's two things that are completely not included in the scenarios of the IPCC, but probably have a very profound effect on global climate. The Earth's geomagnetic field is, probably know that the geomagnetic field has periodically throughout Earth history disappeared completely. Sometimes it's disappeared and come back with reverse polarity. Well, that geomagnetic field acts as a buffer, which helps to reduce the amount of cosmic rays penetrating the atmosphere.
How's it disappeared completely?
I don't know. And I don't know if really anybody knows. I haven't kept up with all of the most recent research on geomagnetism. But, when you go out and you hold a little compass in your hand and it points to north, right?
Right.
Okay, that's the geomagnetic field that's being measured by the compass. It's moving, it's fluctuating. And for whatever reason, throughout the history of the Earth, it has completely disappeared at some points and has reversed polarity. It was the reversing of the polarity of the geomagnetic field that helped prove the reality of continental drift. Because as the mid-Atlantic ridge separates and lava flows out, it crystallizes, and locked into the crystalline structure of the lava is the direction of the magnetic field, and the polarity of the magnetic field is imprinted in there. If you look at the research going back to the 1950s, they realized that you had stripes effectively as you moved away from the mid-Atlantic ridge, as the lava flowed out and crystallized, locked in the geomagnetic field. They looked at it and they could see that there were times when it had completely reversed itself. And so this was like very powerful evidence that the theory of continental drift was right, that the Atlantic Ocean had been spreading. And getting back to this whole Atlantis thing, which is interesting to me, is because when you look at read Plato's account, he describes Atlantis as being west of the Pillars of Heracles, which of course is the Straits of Gibraltar, the mouth of the Mediterranean. He describes how if you come to some islands, then you come to some more islands, and that was the island complex of Atlantis, and beyond that was another whole continent. He describes that, right? If you look in the middle of the Atlantic Ocean, you've got the Azores Plateau, which is now a couple of thousand feet under the sea. The Azore Islands are the tops of mountains that emerge from the surface of the ocean, right? And they sit right on the Atlantic, the Mid-Atlantic Ridge. Now, the Mid-Atlantic Ridge is some of the thinnest crust on the planet, right? And it's like a giant suture or a giant crack that runs up halfway around the planet. Well, when you have an ice age and you start piling ice up onto like the North American continent, what happens is the weight of that ice begins to crush the crust of the Earth down into the mantle. It's called isostasy, which is a vertical movement. Continental drift is horizontal. Isostasy is vertical. Now, it's just like right now, you're sitting on that soft chair, right? And your ass is creating a depression in the cushion of the chair, right? That's isostatic depression. You didn't realize that, did you?
No.
That your ass is creating isostatic depression, right? And when you get up and you walk away, then you will have isostatic compensation. You'll have isostatic rebound because the cushion will now rise because the weight has been removed. It's the same thing with the ice mass on the continent. The ice mass was hundreds of billions of trillions of tons of ice. It pressed the center of the North American continent, or the center of at least Canada, down perhaps as much as several thousand feet into the mantle. With the removal of that ice, the land begins to rebound. Hudson Bay is the depression left over from the thickest part of the ice, right? Now, there are photographs. We could probably even pull some up here in a minute. There are photographs taken where you can see the elevated shoreline surrounding Hudson Bay because it's still rising, right? What's interesting, too, is if you look at the distance between these shorelines, you'll see that early on there's a greater distance because the land was rising faster. As the millennia have gone on, the distance separating each shoreline has diminished. But now you have to think that all of that weight is being transferred back into the ocean basins. A lot of it was dumped directly into the Atlantic Ocean, either via like the St. Lawrence River up there, the Hudson River up in the New York area, or via the Mississippi River into the Gulf of Mexico. Now you've got all this water dumping back into the ocean. Like I said, ocean levels are coming up hundreds of feet, right? So now you're adding all of this weight to the ocean basin. And now you've got the Mid-Atlantic Ridge, which is some of the thinnest crust on the earth, right? This is what it's doing. It's like a hinge line, right? So now you picture during a glacial age, when the weight is taken out, it does this.
Lifts up.
Lifts
Folks
up.
Listening, not watching.
Yeah. When the ice melts, the water goes in, sea level rises, it subsides, right? Now, you look at the Azores Plateau as a chunk of the African plate that got left over when the continents separated around 70 to 80 million years ago, right? If you've seen the maps and the showing how you can fit the continents
Pangea.
Together. Yeah. If you fit these back together, if you reverse continental drift, go back about 70 or 80 million years, and it all fits together like a piece of the puzzle. But when it's separated, a piece of the African plate got left behind. And this is what is the Azores Plateau. And it sits right there astride the Mid-Atlantic Ridge. It's maybe a little bit smaller than Iceland, which is considered to be an island, but a pretty good-sized island, right? Now, if you're doing this, and you have as much as 2,000 or 3,000 feet, or maybe more, of this vertical movement, right, and you add to that the 400 feet of sea level rise, now you can, I think, begin to get a scientific rationale for how you may have had a large island in the mid-Atlantic back during the Ice Age. Also, additional evidence has suggested that the Gulf Stream, which now basically brings subtropical warmth up to northwestern Europe, I mean, if you were to terminate the Gulf Stream, England would have some pretty malignant times. So would northwestern Europe, because the warmth is being brought up by that Gulf Stream, right? Well, during the Ice Age, the Gulf Stream diverted to the south at about 45 to 46 degrees, which was hundreds of miles farther south than it now goes. So essentially, if you look at the Azores Plateau, a big chunk of that Azores Plateau would have been above sea level during the Ice Age, and that Gulf Stream with its warmth would have just basically embraced it, see? So if you suddenly, Joe, found yourself transported mysteriously back to the Ice Age, that's probably where you might want to go, is the Azores Plateau. It might have been one of the most benign places on Earth to live during the Ice Age. And if there was a place where civilization could evolve, that would be a very logical place for it to occur. There's nothing really pseudoscientific now about assuming that there could have been some type of historic reality behind these stories of Atlantis. Of course, the problem is the woo-woo factor that has gotten so grafted onto these stories. But, you know, crystals and aliens and flying ships and, I mean, we don't know, but, you know, we don't have any hard evidence. But the hard evidence does suggest that there could have been some very benign habitable islands, large islands in the mid-Atlantic during the Ice Age.
Wow.
So
that's intense. That's so incredible. It's so crazy to think how much things have changed while human beings have been here. The idea that during Göbekli Tepe, which is 12,000 years ago, that North America was covered with ice. And this was when these people in Turkey had created this incredible structure. So when you see this the modern hysteria about global warming, which has really essentially been like a wrestling match between the left and the right.
Yeah.
It's this weird thing where the right wants to support like burning coal, and they don't want to diminish the economy by putting all these environmental regulations on natural resources. And then the left, which is screaming at the top of their lungs that the sky is falling, the oceans are going to rise, and people are going to drown. When you know so much about what has happened over the course of the Earth, when you've studied this for a great deal of time like you have, what is your take on all this stuff?
Well, I guess my take is fairly simple. I tend to think that, if you look at the whole process of, if you look at the carbon cycle, for example, what you see there is interesting. We have
If you can talk into this as much as possible, so
Yeah.
we can have as little variation in the tone as possible.
Thank you. Putting this into context, we have to say right now we're approaching 400 parts per million of the ambient amount of CO2 in the atmosphere. At the beginning of the Industrial Revolution, it was about 100 parts per million less. You could say basically that over the last century, we have increased the amount of CO2, measurable CO2 into the atmosphere, assuming that it's all from us now. I mean, there's questions about that too, because if there are other factors inducing global warming, such as changes in solar irradiance, the amount of insulation penetrating the atmosphere, and so on, it means that the oceans are warming as a result of that, okay? Oceans are a gigantic carbon dioxide sink. When they're warm, they exude carbon dioxide. When they're cold, they absorb it, right? So if you have a natural warming, it's going to expel some carbon dioxide. So it's not even clear necessarily that 100 parts per million is totally the result of fossil fuel burning. But for the sake of argument, let's say that it is, okay? 100 parts per million, that's a minuscule trace of this very important constituent of our atmosphere. You know that carbon dioxide is what fuels photosynthesis, right? And if you start reducing the amount of carbon dioxide in the atmosphere, and once you start dropping below 200 parts per million, and you get down to about 150 to 100, plant photosynthesis starts shutting down. I mean, it's kind of like the amount of CO2 in the atmosphere right now is at the very bottom of the scale. If we look at history going back when you mentioned the Cretaceous Tertiary, when the dinosaurs ruled, there have been many times more the amount of CO2, up to well in excess of 1,000 parts per million, several thousand parts per million in the atmosphere. But if we have increased the amount of CO2 by 100 parts per million in 100 years, it means for every million molecules of air up there, we add 1 molecule of CO2 every year. Or to maybe try to make it a little bit more comprehensible, if for every 100,000 molecules of air up there, every 10 years we add 1 molecule of CO2. I'm not convinced that that's going to lead to global catastrophe. I mean, think of it this way. You got a huge tank with 100,000 fish in it. Every 10 years you throw in 1 more fish. Are you even going to notice that? I think that what's happened is that CO2, like I said, is one variable in a very complex equation. But all of the other variables, as far as the government-funded research goes, have been excluded from the debate. And what dismays me is that we're told that all scientists agree on this. No, all scientists don't agree. When you have, though, a major government-funded program like climate change research, which is funded to the tune of about $2 billion per year, you're going to have a large vested interest in basically, I mean, if these guys came out and said, CO2 is really not a big deal. It's perhaps fueling plant growth. And this is an interesting aside. If you look at the projections of forest inventory back in the 50s and 60s based upon deforestation as a result of timber, as a result of agriculture, the projections at how quickly forest inventories were going to rebound. If you look at those projections back in the 50s and 60s, and then you realize that in the ensuing period of time, we've now got exhaustive, highly accurate satellite surveys that can actually count the number of hectares of forests. What's interesting is in the 90s, when they really started looking at this data of just how much forest there was compared to what the projections were, there was like 25 to 40% more forests worldwide than anybody had predicted. What fueled this prolific forest growth? Well, it's very likely that at least part of it was because of the slight increase in CO2 as a result of our fossil fuel burning. Now, we put in, every year we burn about, introduce into the atmosphere about 6 billion tons of CO2. Well, there's about 750 or 760 billion tons of CO2 in the atmosphere naturally. And at least a third of that is cycling through from atmosphere into the biosphere, into the oceans, and so on. So our contribution isn't really that significant. But another part of the argument is that, and this has been admitted right in the IPCC reports, is that based on the amount of fossil fuel that we're burning, there should be twice as much CO2 in the atmosphere as we're now measuring. So what they have been talking about for about 15 years now is, where's the missing carbon? What's this missing carbon sink? Well, probably some of it's going into the ocean, but most likely a lot of it is going into fueling plant growth and forest growth worldwide. And there's a lot of studies that are beginning to come out now that shows that perhaps some of the desert areas of the planet, rather than expanding, are actually contracting. So, at this point, there's a lot of things we still have to learn. When it comes down to understanding the climate, we're in the infancy. You can't talk to a single climatologist and come up with one single coherent answer or agreement on what has actually provoked the planet to go into a full ice age or what has caused it to come out of an ice age. If you don't know that, we still have a hell of a lot to learn about how the climate works. So I get really frustrated when I hear this claim that the debate is over. The debate is over. Because the debate hasn't really even begun yet. You see, we need to really look at all of these other factors as well. I mean, when you look at wind currents and ocean currents, you have the El Nino Southern Oscillation, you have the Indian Ocean Dipole, you have the Pacific Decadal Oscillation. All of these things have a very profound influence on the climate. But they're essentially being ignored within the government-funded science to a large extent. And you have a lot of scientists who have objected to some of the claims of certainty made by the IPCC scientists. And for the most part, the left likes to demonize them. This is people like, I think probably the leading demon of climate deniers is Fred Singer, because he once was given a $10,000 unsolicited donation from Exxon years and years ago. But you've got guys like Roy Spencer and Craig and Sherwood Idso and Robert Balling and Timothy Ball and the list goes on and on. These are distinguished climate scientists that have devoted their lives to understanding climate science who say, well, there's a lot of flaws in the methodology of the IPCC. But by saying that, now they have entered the spawn of hell, according to the left. Now, and you're right. See, what happened, it's turned into a political football.
It's an ideological debate.
It's an ideological debate, a political debate, and it's just too bad that the science of the thing has had to suffer in the consequence.
It is fascinating because even hearing you say this, I'm thinking, like, it starts popping triggers. Like, I'm not the type of person that worries too much about being labeled, because I've been labeled a million times already as an idiot. It doesn't bother me to start contemplating the possibilities of controversial ideas. But when I'm listening to you saying this, all I'm hearing is the knee-jerk reaction of climate denier. He's a climate denier. This guy's a climate denier. And seeing these fucking things that we've grown to be accustomed to on television, where you have a guy on the left who has one point of view and a guy on the right who says something wacky, and then everybody fights about it. And, and then the YouTube clips, you look at the comments and it's filled with this guy's a faggot and that guy's a fucking, this guy eats shit. I hope your house goes underwater, you fucking climate denier. It's just, and when I'm listening to you, and this podcast has been over an hour already, and it's incredibly complex. We have barely scratched the surface, and you're never going to hear anything like this on any television show because most people feel that the general public does not have the attention span to absorb all of this information, this really complex explanation of the known science of the changing of the atmosphere of the Earth. So when people start talking about climate denying and what is going on with climate change, what they're really doing is establishing their position on what side. I'm a rational person who believes in science and education, but how much of this have you actually explored? How much of it has anybody actually looked at? Well, I'm a person who supports industry, and I'm a person who believes the United States needs to recover from our economic disaster, and if we got to frack a few wells, so be it. There's these two very distinct and oftentimes shallow ideological perspectives. And when I say shallow, I mean shallow from the point of the general public, a person like me who's not a scientist, observing it and just picking a side with very little information, really. And I would like to grab the average person, the average lefty and the average righty that thinks that they have an opinion on global change, and just do me a favor and just write down what you know. Just write down. I don't want you looking online. Do you have an opinion? Write down what you know. You know dog shit. Most people know dog shit.
It's true. It's true, Joe.
It's so fascinating. It's so fascinating to me because it becomes another one of those things. Ideology is, I don't remember who said it, but it's the enemy of free thinking. Mm-hmm. You get in these ideological clusters. And then anything outside of this thing, these predetermined patterns of behavior that you've subscribed to, anything becomes forbidden. Mm-hmm. It becomes, you can't even entertain it. You can't even approach the idea. You see it with everything. You see it with atheism. You see it with any isms, with feminism, with the men's rights. You see it with people who subscribe to the right, people who subscribe to the left, any variables that don't fit into their equation that they've already subscribed to, they don't want to be labeled as that other side. And anytime they don't want to be labeled, they start ignoring any evidence or any ideas that don't fit within this really rigid description.
That's exactly right. That is, you hit the nail on the head, Joe.
We're
that's
so weird.
Exactly right.
People are so weird.
People get locked into these ideological paradigms, and then from that point on, basically their perspective is modified more by emotion and rationality.
Yes.
More by, their feelings rather than real information. And it's too bad. I don't know what to blame it on. Maybe the fact that the government runs all the schools. I don't know. The government monopolizes the education system, so they're not teaching people critical thinking skills. They're not teaching people how to be scientifically literate, which is really sad. But it's like we keep hearing the term climate change denier, mm-hmm. right? Well, there's no such thing. I don't think you're going to find a single climate scientist of any persuasion that denies that the climate is changing. And you got to realize that the terminology has shifted. It was global warming originally. When James Hansen gave his testimony before Congress in the summer of 1988, and proposed these potential tipping points and catastrophic outcomes of our burning of fossil fuel, we've gone from there to the United Nations getting involved, and the United Nations setting up the IPCC and channeling all of this funding to it. And I think the consequence is that, when you say, again, excuse me, we went from global warming to climate change. Why do they not really use global warming as a term anymore? It's mainly because for 15 years, the average global temperature has flatlined. And this is based upon, the most accurate, like satellite surveys. The IPCC generally focuses only on ground-based sensors, which are subjected to perhaps some considerable bias because, you picture a ground-based sensors, most of them are sitting at airports. When these things were being put in post-World War II, the bulk of them, 40s and 50s into the 60s, many of these airports were rural. They were, adjacent to small towns. They were surrounded by fields and farms, forests. What's happened is the urban area has encroached. When you create streets, pavement, buildings, all of this absorbs heat, right? And no one has really done an exhaustive study of the potential bias that's introduced into the ground-based sensors. That at least part of the warming of these ground-based sensors may have nothing to do with carbon dioxide at all. It may just have to do with the fact that they're sitting next to a huge parking lot, you see. And I mean, yourself, if you walk out, if you're walking in a field and then you walk onto a asphalt parking lot, immediately it's much, much hotter. You see, Anthony Watts, who's another one of the dissenters who's demonized, is the only one who has really attempted to exhaustively document the accuracy of the ground-based sensors. And what he's come up with is that perhaps as much as 30 to 50% of the perceived warming of the last century, which is about 0.8 of a degree centigrade, is probably as a result of that bias that's been introduced by what's called the urban heat island effect. And all of the major cities, LA has a urban heat island mitigation program underway. All of the major metropolitan cities are now trying to mitigate the effects of this heat because of all of the cement and the buildings and the pavement and the parking lots. They're always hotter than the surrounding rural areas. So the question has been legitimately raised: how much of a bias has been introduced into the ground-based sensors? Well, when we turn to the balloon sensors, the radiosonde balloon sensors and the satellite sensors, basically what they're showing is that the average global temperature has been flat for 15 years. Well, because of that, and many of the key scientists like Phil Jones of the IPCC has basically publicly admitted, when you look at the average temperature from that perspective, it hasn't warmed in 15. Yeah, now, there are regional pockets of warming and, records being set all the time because local conditions will affect change enormously. Just like I was talking about the urban heat island effect is a local or regional condition. But because of the fact that the climate hasn't warmed statistically significantly in 15 years, now we don't talk about global warming, we talk about climate change. But those two terms are not interchangeable. Global warming is a very specific model of climate change, which is that you've got this 15 micron wavelength of CO2 in the atmosphere that's trapping infrared radiation emanating from the Earth. Right? Okay, but if you're talking about climate change, now suddenly, our umbrella goes much, much huger, and it now encompasses all of these other things that I was talking about. And to question the consensus idea, to question that CO2 is the primary or sole driver of climate, is not to be a climate change denier, see? Because I would challenge anybody who even uses that term, well, show me an example of any climate scientist, no matter where they fall in the argument, that is denying that the climate is changing. I mean, anybody who has studied the climate at all knows that it has changed dramatically and dynamically on any scale you can look at, whether it's the decadal scale, the centennial or millennial or beyond. It changes on every level. And that's the thing we have to recognize, that if we stop burning fossil fuels tomorrow, we didn't drive another car, we shut down all the coal plants, I'm going to tell you this, the climate would not stop changing.
When you see a story, like here's one, it's in the news, about U.S. Senator Marco Rubio's denial of man-made climate change should play well with his Tea Party base, whose support he'll need if he indeed runs for president in 2016. But in taking this position, Florida's junior Republican senator ignores the vast majority of the world's climate scientists who say human activity is contributing to climate change and rising sea levels.
Human activity is contributing to climate change. No doubt. There's no doubt that human activity contributes to climate change. Human activity, again, is one variable in a very complex equation. I wish Marco Rubio would keep his mouth shut until he goes and spends about 6 months or a year really doing the homework, because then he could talk a little bit more intelligently about it.
But that is the problem, right? It really does take that long.
It does.
Like, I know you, when did I meet you? Like 6, 7 years ago?
Something like that, yeah.
And you had already spent decades observing the effects of climate change and of asteroidal impacts and the history of these things. I mean, the amount of time just absorbing the information so you could rattle it off like this in a podcast. I mean, what the fuck got you into this? Like, how did you get down this rabbit hole?
Well,
this is an odd rabbit hole, right?
It's an odd rabbit hole.
It's a fascinating rabbit hole. I'm so thankful not only that you've gone down it, but that you're willing to exchange this information with us or impart it on us, because it's a very different perspective, because I know you're not a right-wing lunatic. You're a very science-based guy, but you're looking at this, and the way you're explaining it is incredibly rational and incredibly frustrating to me that there's not that many people that are saying this.
Well, the upside, I think, of the whole global warming issue or the climate change issue is this, that if, the thing is I made the point that even if we stopped all fossil fuel consumption tomorrow, the climate is still going to change. And it's going to change dramatically. It's going to change sometimes even catastrophically. What we need to do from here on out is basically think about strategies of adaptability. If, as a result of this whole issue, even though I think it's misbased, misapplied, if part of it that comes out of this is that we begin to develop strategies of adaptability, that would be a good thing. If, however, we focus so exclusively on carbon dioxide to the exclusion of everything else, that could be a bad thing. Because the climate is going to change. No matter what we do or where we go with it, the climate is going to change.
So you can put up solar panels until the cows come home. The houses that are on the beach in Malibu are still going to be underwater in 100 years.
Well, not necessarily.
Not necessarily. So buy real estate in Malibu.
Well, see, the thing is, if you look at I mentioned earlier that there was a break in the Little Ice Age of about 150 years that basically led to the Renaissance, right? Well, we've been in a recession of the Little Ice Age, an interruption of the Little Ice Age for about 150 years. And right now, and again, the IPC, one of the things that frustrates me is that they basically exclude solar physicists and solar scientists who are essentially saying that insolation, the amount of solar energy penetrating the atmosphere, is at one of the lowest levels in thousands of years. And I mean, there are solar physicists that are saying, you know what, we could be at the beginning of another phase of the Little Ice Age. Now, if our CO2 is helping to ameliorate somewhat a return to the Little Ice Age, that would be a good thing.
So muscle cars are green.
Yeah.
That's what I'm getting out of this. Coal and muscle cars are good for the forest.
Well, the problem with coal is not so much the CO2 as to me is just the particulate matter.
Right.
That's a different question altogether.
The pollution. Which is horrific in China when they have these coal plants. You see these people that are essentially walking. It looks like they're in the middle of a forest fire. They're walking down the street and it's just dark everywhere.
See, that's a different issue.
Right.
And I consider myself a conservationist in the respect that we basically need examples of pristine nature, because ultimately nature is the most powerful teacher. And we need examples. We need places where nature is just left alone to do its thing without interference of human beings. We need clean air. Nobody has the right to dump shit in the air that other people have to breathe. Nobody has the right to dump shit in the water that other people have to drink. To me, those are different questions, and really where more of our focus should be, rather than these abstractions. I have found, of course, I've gotten some flack over the last few years by saying some of the things I've been saying here, that I've had people stand up and accuse me of, you say we can just do anything we want. We can just destroy the earth, which, of course, is not the case. And
You're not saying that at all.
Not saying that at all. And when we begin to look at the bigger context of this thing, and we begin to understand that the extraordinary changes that this planet has been through, and even to some of the lesser things in recent years, Mount St. Helens, you remember when that erupted in 1980? Tens of thousands of acres were turned into a lunar landscape, right? Well, if you read the accounts of the scientists, the biologists, the zoologists, the ecologists that have been studying what happened to that decimated landscape in the aftermath, what you find out is they're surprised and almost shocked at how quickly nature recovered from that, and how quickly colonizer plants moved in, and was followed by the whole succession, the ecological succession of reclaiming that land. If you look at the Exxon Valdez disaster up in
Alaska,
that was, over the short term, devastating to the local ecology. And yet what's interesting, again, there have been several books written by some of the lead scientists involved in that, talking about how remarkably quick nature began to reclaim and recover from that. And here's some irony. Where the government forced Exxon to go in and do its cleanup has actually suffered more than the areas that were just left alone for nature to reclaim.
That's fascinating. So the chemicals that they used in order to break up,
that
was the issue with the Gulf as well, right? With those dispersants that they were spraying over the area.
They probably should have just left the Gulf alone because, when you have submarine earthquakes, they can expel huge amounts of hydrocarbons into the ocean. Nature has been dealing with massive expulsions of hydrocarbon into the oceans and into the marine ecologies for millions and millions of years. It was bad, but I think, what we'll see is that the recovery time has been faster than most people believed possible. You see, I think what's really going to turn out in the end, looking at all this, is that nature is robust. And when we begin to look at the number of times that nature has been disrupted by, we've been talking about asteroids and comets and things. Here's a perspective for you. At the peak of the Cold War, when U.S. and the Soviet Union were eyeball to eyeball with our nuclear weapons on high alert, and we had 10,000 weapons on our side, they had 10,000 weapons on their side. The total nuclear arsenal at the times had about 18,000 megatons of energy capable of being delivered. 18,000 megatons. Now that means 18 million tons of TNT. The bomb that destroyed Hiroshima was about 10,000 tons of TNT. So 100 times, 100 Hiroshima bombs would be 1 megaton, right? Now, there was about, say, 15 to 18,000 megatons total in the arsenal of the superpowers during the height of the Cold War. Had we unleashed an all-out nuclear war and fired every warhead that we had in our arsenals at each other, 15,000 warheads, 20,000 warheads, 15,000 megatons, it would have been an environmental disaster unprecedented in history. You remember the scenarios about nuclear winter, right? Because of all of the fires and the soot and the particulate matter thrown into the atmosphere, it could literally bring on a mini ice age, right? And probably cause, without even the radiation, cause major collapse of the human population, right? Get this number in your head, 15,000 megatons. Okay, now, even a small asteroid impact, or let's say the asteroid impact that struck the Yucatan, there's a simple formula that you can use. When you look at the crater size, you take the size of the crater and raise it, expressed in kilometers, raise it to the power of 3.4, and multiply the result by 2.4, and what it's going to give you is the energy yield in megatons of that object striking. If I put in 180 kilometers into this calculator here, which is the diameter of the Yucatan crater, and I raise it to the 3.4 power, and then I multiply that by the 2.4 power, I get the megaton yield, all right? That number comes up to be 111 million megatons. I divide that by 15,000, and basically what we have there is about equivalent to the entire nuclear arsenal of the superpowers 8,000 times over. 8,000 times over. Now, what kind of an environmental consequence would there be to that? Well, we saw that global firestorms, the studies of the amount of soot at that boundary layer shows that the amount of biomass that went up in firestorms at the KT boundary was about equivalent to every plant on Earth today going up in fire, right? Wow. You had tsunamis that were perhaps 1,000 feet in height. You had global earthquakes, probably measured 10 to 11 on the Richter scale. And you know how the Richter scale works. It's logarithmic. So that an 8.0 earthquake is 10 times more powerful than a 7.0. 9.0 is 10 times more powerful than an 8.0. An 11.0 earthquake is going to be unimaginable. The whole framework of the globe would have shaken. You probably would have massive failures on every fault line on the planet. Now, the KT event was the middle of the 5 great extinction events, right? There was Ordovician, Silurian, there was the Permian Triassic, there was a couple more. 2 of them were more extreme than that. Now, even much smaller than that, right? When they talk about a tipping point, are we talking about a tipping point that could trigger a climate change, a disastrous, catastrophic climate change, as being a few parts million more of CO2? Or is a tipping point really a mile-wide asteroid slamming into the Earth at 100 times the speed of a rifle bullet? That could be a tipping point, my friend. Jesus and that Christ. Has happened thousands of times and hundreds of times since we humans have been here. Hundreds of times.
Hundreds of times.
Hundreds of times.
And when was the most recent one? That was the Holocene crater?
Well, probably. There's evidence emerging now that the collapse of the late Bronze Age civilizations around 4,200 years ago may have been precipitated by a series of impacts. There's evidence emerging that the climate downturn that occurred between 536 and 540 AD that I talked about earlier may have been triggered by a series of multiple impacts. One that looks like it occurred off the coast of Norway and another one that looks like it occurred off the coast of New Zealand, like tandem impacts, right? Around 536 AD. And we're basically faced with the idea now that literally impacts from things from space may be hundreds of times more likely than anybody was even imagining, a generation ago.
So we're essentially this civilization that is banking on the knowledge that we've accumulated over a very small amount of time, and as we're uncovering more and more evidence, more and more information, we're starting to realize our ignorance. We're starting to realize how little we know about our own history, the history of this particular species and how it's interacted in this crazy, volatile environment of Earth, and how many times we've been hit by rocks.
Yeah. And see, 100 years ago, the assumption was...
What are these images? Are these craters or impacts?
Yeah, that's actually 10 years old, but it shows now all the identified impacts.
And this is 10 years old, so since then some new ones have popped up.
Dozens more, yeah.
And since then has been the discovery of this nuclear glass that they've found all over Europe and all over Asia.
I think, are you referring to the thing that Graham was talking about, the 13,000 year ago event?
I think that's what it is. What I'm referring to is there was a mainstream report about all these pieces of this very similar material to what they find at nuclear blasts.
Yes.
And that it was all over the place when they did the core samples around 12,000 years ago.
Yes, then that's exactly what Graham's talking about.
Yeah.
And yes, the evidence is getting stronger and stronger each year that there may have been a multiple impact event that terminated the Ice Age. And this is still a very controversial idea because the gradualists just don't want to go there.
And this is probably what killed off mass extinction of the woolly mammoth, mass extinction of the saber-toothed tiger.
Yes.
And a series of animals that they really have not figured out why. Like, there's been all sorts of theories about why the woolly mammoth went extinct, and some of them are ridiculous, like that people did it. You know,
I'm glad to hear you say that. That's a ridiculous idea.
well, it's ridiculous when you think about what kind of people were around 12,000 years ago and what kind of weapons they had and what a fucking mammoth looks like. Like, Jesus Christ. How many of them were? And the other thing that's ridiculous about, I mean, obviously, when I say ridiculous, I'm ridiculous. I shouldn't even be making that statement. I've done very little research. But the research that I've read and the people that have questioned it have talked about the mass graves where they've found these animals that have died instantaneously, thousands of them, and not consumed either. They don't show signs of predation or of butchering. They've died in full form, full body.
Yes.
And they've massive amounts.
Graveyards. And you know, for centuries, pristine mammoth tusks, ivory, have been hauled out of the permafrost of Siberia in trainload lots. You know, and this has gone into the global ivory market literally for 300 or 400 years. Some estimates are that there may have been as many as 4 to 10 million woolly mammoths worldwide. Most people don't realize that right here in North America, there were 3 species of proboscidean or 3 species of elephants during the Ice Age. Africa has 1 species. India has another species. We had 3 species here.
During the time when Göbekli Tepe was being built.
Yes.
Wow.
During the time.
Elephants.
And yeah, elephants. And here's another perspective.
Is that one that they found? What is that?
This is the Beresovka mammoth that was found in 1901, quick frozen. With flesh. Now, at the time this photograph was taken, wolves had eaten the flesh off of the skull. That's why it's bare. But what you see there immediately.
Dirty wolves.
Yeah.
Eating some million-year-old meat. Disgusting assholes.
Probably 13,000-year-old meat.
So
that's a little, not quite as bad as million-year-old meat.
Still disgusting. Disgusting animals.
But you can see the mammoth's left forelimb just in front of his face there. You see how it's, and if Jamie toggles back and forth between this image and the next one, you'll be able to see, this was how the woolly mammoth was found. And
so they took photos of it when it was found like this, and then they left it alone, and the wolves came and got it?
This is a reconstruction. It was, I believe, in the Leningrad Museum. So what they did was they took the remains of the woolly mammoth, and then taxidermists came in and reconstructed.
Oh.
But this shows the position in which he was found, sitting on his haunches like that. And at the time that the woolly mammoth met his demise, he was eating flowering plants. Right? Now, it's important to keep that in mind. His stomach was full of about 24 different varieties of plants and sedges and things that he had been munching on up in Siberia at the time that he met his death. Number of interesting things. The contents of his stomach had not putrefied, right? Now, that's mysterious. The fact that his flesh was still edible, at least by wolves. You know, the stories about the scientists eating mammoth burgers is probably made up. But the wolves definitely were able to eat the flesh, right? It was described as still being marbled, almost as if it had just been frozen, a week ago. But since the time that the woolly mammoth died, it had its whole carcass. Now, this was a 6-ton woolly mammoth. So it had been frozen for how many thousands and thousands of years, and so thoroughly frozen that the contents of the stomach had not putrefied. Now, a woolly mammoth of 6 tons has a lot of internal heat, right? Clarence Birdseye, the founder of Birdseye Foods and the inventor of the fast freezing of foods for preservation, got involved in examining and speculating about this woolly mammoth. His conclusion basically led to something like this. In order to prevent the contents of the stomach from putrefying, the entire carcass of the woolly mammoth would have had to have been frozen through and through in 10 hours or less. Now, bear in mind that this woolly mammoth was eating flowering plants, right? Now, how cold would it have to be to freeze a 6-ton woolly mammoth in 10 hours or less? His estimate was probably somewhere around 150 degrees below zero.
So from flowering plants to 150 degrees below zero in 10 hours.
In 10 hours.
What causes something like that?
Well, there's been some speculation. The speculation that I found most interesting was possibly volcanic gases that had been ejected up into the stratosphere, approached absolute zero, and because of the cold, fell back to Earth. I think you could get the same effect perhaps with gases released from a disintegrating comet nucleus. It's still a mystery. I mean, anything that anybody says at this point is purely speculative. However, it's clear that whatever this mammoth underwent was disastrous in the extreme. You saw him sitting there on his haunches, right? Both of his hip bones were broken, which means that he was slammed back onto his haunches very violently. He was also found with an erect penis, which means that he died by suffocation, which meant that he was entombed virtually instantly by the material that later became the permafrost. We were talking about the Little Ice Age earlier, and I was talking about how the Little Ice Age ended around 1850. Well, this guy was found about 1901 after the climate in Siberia had been warming somewhat, see? And what happened was a part of a cliff that had been next to the Berezovka River, the Berezovka River had shifted its channel and eroded some of the cliff face back. And then one warm spring, there was a collapse of the cliff face that exposed this mammoth to the atmosphere.
Wow.
And at that point is when the wolves came in and began to devour the flesh on the skull, see? So clearly this woolly mammoth is an example of or indicative of some type of a catastrophe. Whether it was a global catastrophe or a local catastrophe, nobody knows. But clearly it was catastrophic. But that woolly mammoth is only one of dozens of examples of flash-frozen late Pleistocene mammals that died under similar circumstances.
And these large graveyards of mass extinctions of thousands and thousands of animals, what are the best examples of them? Because I know that I've seen some of them online, but I can't pull them up like I'm sure you can.
I've got some right here if I can get my laptop to... pull up, look towards the bottom of the list, you'll see Pleistocene, the lost world of the Pleistocene. Do you see that?
And there's PDFs?
No, it's a PowerPoint.
Okay.
It's in that list of the PowerPoints that I gave you. I have some photographs.
You're freaking me out. I just want to tell you right now, you're freaking me out. And
Well-
I get freaked out pretty easy, but but you're freaking me out. The
Well, I
flash
actually-
frozen mammoth.
I have to confess that one of my objectives in coming here was to try to freak you out.
Well, you did it. Congratulations. You're successful. I've been terrified of Yellowstone for years now. I've watched some late night documentary. It was a huge mistake. It was one of those things I was about to go to bed, and I was just flipping through the channels, and they were going over this thing about a caldera volcano in Yellowstone. And I was like, what the fuck's a caldera? And then they started talking about how it's, what was it, something like 600 kilometers wide or something
Yeah.
crazy like that, which is something like 300 miles. And they were saying that they didn't even discover it until they started doing satellite imagery of Earth, and then they realized that, oh, this was a giant volcano that was so violent in its eruption that it blew the mountain off of it, and it became this massive crater, and that it happens every 600,000 to 800,000 years ago, and that the last time it happened was 600,000 years ago.
Yeah.
Yeah.
So hopefully, keeping our fingers crossed, we got another 100,000 years.
If we're lucky.
Yeah. But see, that's another aspect of this component of the dynamic history of planet Earth is these gigantic volcanic eruptions. There's been some interesting work linking asteroid impacts with giant volcanic eruptions as well. And it would make sense that that the energy injected into the Earth by a major impact could trigger volcanic eruptions. We know that during the great meltdown event of 11 to 13,000 years ago, that there were enormous, massive volcanic eruptions. And Mount St. Helens, for example, was massively erupting at that time. And I have some photographs right here. I don't know how much time we have to look at some of this, but where I have gone out and have found thick layers of white volcanic ash from Mount St. Helens sandwiched in between these flood layers. And it shows that, and it undoubtedly had to have been a response to the fact that you had this enormous mass transfer of weight that we were talking about earlier from the continents back to the ocean. And when we go through, and maybe it's time to go through a few of these images that I brought so you can begin to see some of the consequences of this melting. And you begin to appreciate that, yeah, there were these just enormous mass transfers of weight, unloading in certain areas, loading in other areas. This would clearly have a profound effect on the subterranean stability and could easily lead to major eruptions. And there was a spasm of major volcanic eruptions globally at the time of the transition out of the Ice Age, which would only have added to the havoc of that transition. And why, half of the great species of megafauna disappeared. A megafauna is basically defined as any animal, in this case mostly mammals, over 44 kilograms in body weight, which is about 100 pounds, right? So that would include us. And if you started thinking about all of the animals globally, worldwide, that are more than 100 pounds, depending on how you divide up the species, there might be 100 to 20, 130 different species. And I'm talking about the lions and tigers and bears and elephants and rhinos and hippos and moose and caribou and ... right down the line, right? Okay, let's go back to the Ice Age. The extinction, the loss of species at the end of the last Ice Age was about equivalent in number. The loss of species of megamammals was about equivalent in number to the number of species of megamammals that still exist. So in other words, these events that terminated the Ice Age basically decimated half of the species of megamammals on Earth. Half of the species disappeared. So if you were going to try to affect an equivalent mass extinction of species today, you'd basically have to eliminate every animal on Earth over 100 pounds in body weight in order to get the equivalent of that mass extinction episode of 12,000, 13,000 years ago.
That's insane.
It's insane, but it's absolutely the truth.
What is the official, or mainstream explanation for this?
It doesn't exist. Okay, you brought up the idea of it's called overkill, which has been the dominant theory for decades, which is that human hunters exterminated the woolly mammoth. And in some vague way, the extermination of the woolly mammoth, being at the top of the food chain, somehow had a ripple effect down, through the ranks of species, and somehow, perhaps, in an unaddressed way, resulted in the loss of all these other species. But they just don't address that. And the more you said that theory is ridiculous, and that's an understatement. I mean, you're talking about, perhaps bands of few hundred or maybe even 1,000 individuals, migrant bands, human hunters coming in and somehow able... See, you got to bear in mind that the estimates of human population during this time globally is less than the estimates of the population of woolly mammoths. But somehow our ancestors were able to wipe out 4 million to 10 million woolly mammoths so fast that they couldn't even reproduce.
So there was only 10 million people back then?
That's based upon more or less the conventional interpretation. Now, of course, what we've been talking about opens the door to their possibility of there being a lot more people.
And then mass extinction also including a massive amount of human beings as well.
Yeah, and there is some interesting evidence emerging now that there perhaps was a population collapse between what is called the Clovis culture and the Folsom culture. The Clovis culture appears in North America to be what is believed to have been the earliest culture. And there's a site in New Mexico that was the first discovery of the association of human artifacts, meaning spear points and arrowheads and things like that, along with extinct mammals, right? This is Clovis, New Mexico. It's a very interesting site. I visited there about 6 or 7 years ago because I was looking for this so-called black mat layer, which has now been documented at dozens of Clovis sites around North America. And the black mat layer is this unique layer that essentially separates the Pleistocene from the Holocene. And it's full of soot, it's full of iridium, nanodiamonds, microspherules, and all of these signature things that are indicative of some kind of a cosmic event.
Is this an image indicative of that? Is that what this is?
That's kind of a blurry image, but right there...
You can see it up here, too, so you can face the microphone. There's
yeah,
one up
okay.
this way.
Yeah, the white strip in the middle shows the black matte layer. That's exactly it. And what you see below it are the bones of extinct mammals, and what you see a couple of thousand years later is bones of extant mammals. And nowhere above that black matte layer do you find the bones of the extinct mammals.
What is extant? It means dead that
still exist.
Okay.
You know, bears are extant.
I see.
You know,
That's
woolly
fascinating.
mammoths are extinct.
So there's a very distinct line that can be attributed to some sort of an event.
Yes, some sort of an event.
Something before that, they're all alive. Something after that, they're all dead.
They're all dead.
And a massive amount of the larger mammals gone, wiped off the face of the planet.
Wiped off the face of the planet. North America lost about 75% of its species of megamammals.
Holy shit.
3/4. There we go. There's some of them.
What was that thing below?
That thing below was...
What is that fucking thing? Giant ground sloth.
That fucking thing is the Megatherium americanum. It's the giant ground sloth. It was the size of an elephant.
Oh, my God.
These are the glyptodonts.
These are all 10,000 years ago?
Not this guy.
Well, these are dinosaurs, obviously.
Dinornis maximus is the giant moa. This guy, I threw him in here for Orcus because he's just such an awesome creature.
That's the terror bird, right?
That's the terror bird. Yeah.
Scroll back up. Stop scrolling, Jamie. Look at that fucking bird. That's a 7 foot tall, bigger than that.
9 foot tall, yeah.
A bird that doesn't fly. So essentially a murderous ostrich.
Yeah, and this was the top of the food chain during the Miocene.
Really?
Yeah, this was it. This was the baddest ass predator on the planet for a while.
Really?
Yeah.
More so than a saber-toothed tiger.
These guys existed before the saber-toothed tiger.
Wow.
But they succumbed to one of these global events. You got to bear in mind that if you take a census of all the species that ever existed compared to the species now, it's conservative to say that 99.99% of all species have become extinct.
Wow.
And the ones that and of course most of those went extinct without any help from humans at all.
Stop scrolling. What is that fucking thing?
That's Elasmotherium sibericum.
Jesus Christ.
Yeah. I mean, you begin to appreciate...
It's like a bull that fucked a rhino.
It is, but it's...
Doesn't it look like that?
Yeah.
Wow, that's insane how big that is.
Oh, it was huge. I mean, it was elephant-sized, basically. A woolly rhinoceros the size of an elephant. And this is Coelodonta, which is the classic woolly rhinoceros. And there have been quite a few species of these guys found that were flash frozen.
And this is 12,000 years ago. This thing existed.
Yes.
A woolly rhinoceros.
Yes.
And where
in North America.
Jesus Christ, that's incredible. And what's the mainstream explanation for these things going away?
Good luck on trying to find one. I have looked. There is none. There is nothing. There's nothing.
So is this something that they just haven't formed any theories about, or they don't try to, or it's been ignored because there's not enough information?
It's been ignored, and here's why. At the dawn of earth science, geological science in the early 19th century, to a man, every one of the founding fathers of geology, whether it was William Buckland or Cuvier or Sir James Hall or Rodney Murchison, Adam Sedgwick, you could go right down the line. All of these guys from 1820 up to about 1860, every one of them was a catastrophist. To a man, every one. Because these were guys, basically, who had not been indoctrinated into any particular interpretation of world history. They went out and they looked at evidence in the landscape, and their conclusion was, something really catastrophic has happened. And then what happened was you had Charles Lyell, Playfair, and James Hutton. These three guys came along and basically established the doctrine of uniformitarianism, as it's called, a mouthful, right? And basically the idea of uniformitarianism was this, is that we look at modern processes to explain ancient processes. So if we see a river eroding its bank, moving sediment, creating a sandbar with that. If we see like during the early 19th century, we were in the last phase of the Little Ice Age, so glaciers were receding, and these guys could essentially go up there and look on a year-to-year basis and see what was happening as the glaciers were receding, right? So basically what they then did was extrapolated from modern processes to try to explain all the ancient processes. This is the doctrine of uniformitarianism. Okay, it's a very powerful model for understanding ancient change. However, it became ensconced as dogma, so that by the turn of the century, as we come right up to the threshold of the 20th century, it was now considered unscientific to try to explain anything in the past that we couldn't see happening today, right? So as we go into the 20th century, this gradualist dogma became ensconced in academia. And every geologist from about 1900 up to about 1980 was thoroughly indoctrinated into this idea of the gradualism, that all of the earth change that we see going on the planet today has occurred one grain of sand, one drop of water at a time. And it was considered to be very unscientific to begin to invoke things, because initially some of the founding fathers of geology, well, a lot of them, interestingly, were theologians who oftentimes, a number of them, like Adam Sedgwick is a good example of somebody who was a traveling theologian, a traveling minister, right? He was traveling around England, and he was seeing things like the Thames River Valley, and he was seeing that the Thames flowed in this gigantic channel that was completely outsized relative to the river that was flowing in it. And he says, that must have been from a huge flood. Well, he was a theologian, right? So he said, Noah's flood, right? Well, as it turns out, there are enormous geomorphic effects of gigantic floods all over the planet, right? We know that now, right? In the 1800s, they assumed that if you saw effects of gigantic floods, it had to have been Noah's flood. Well, at the same time that you had geological gradualism on the ascent, biological gradualism came along in the form of Darwinism. And the two sort of complemented each other and mutually supported each other. Well, if we've got infinite time, millions and millions of years of gradual geological change, now that allows us millions and millions of years for gradual biological change. And these two paradigms were mutually reinforcing. So now we come to the 20th century, and for the first 3/4 of the 20th century, that was the dogma that was indoctrinated into the minds of every earth scientist, right? And to vary from that was to be pseudoscientific, and you're trying to revert back to biblical fundamentalism if you start talking about giant floods, right? Well, what happened was, and then it was left to people like Immanuel Velikovsky, who was not an earth scientist, he was a psychoanalyst, and he wrote several books in the mid-1950s where he had gathered together in one place all of this anomalous evidence from the earth history that did not fit the uniformitarian paradigm. Now, his books were popular successes, but mainstream science just slammed him and said this guy's a nutcase, right? Well, he did make some serious missteps in trying to explain this anomalous geological evidence for catastrophe. And it was those missteps that they were able to focus on to try to discredit him. However, the amassing of evidence for catastrophes in Earth history has held the test of time. And what we see is 1980 was a pivotal year. That was a year that 3 separate teams published evidence showing that the Cretaceous-Tertiary boundary, the dinosaur boundary, was profoundly catastrophic. And that opened the door to begin a reconsideration of Earth history. Now, at the same time, with the advent of the space program, we are beginning to realize that near-Earth space is not a completely empty place. It's actually densely populated by all kinds of things, see. Prior to the Apollo moon program, it was believed that most of the craters on the moon, if not all of the craters on the moon, were volcanic, right? Post-Apollo, the realization was that, no, they're not volcanic. They're impacts of things from space, see. Now you look at the surface of the moon, and I think the last image on the Joe Rogan images there is going to be a picture of the moon, and you'll see that it's
Littered.
Thousands and thousands and thousands of craters.
And because it doesn't have an atmosphere and because it doesn't have plants, we can actually see everything that's happened.
And the point, Joe, is this. If we were able to strip away the biosphere, the thick layers of sedimentary rocks, the oceans, the Earth would look like the moon.
God damn.
It would look like the fucking moon.
So it's simply a matter of time and perspective that we really, well, thankfully there's people like you that are paying attention to this, but with the amount of time that people have been videotaping things and writing books, this tiny little window, there just hasn't been enough time to really get a real account of how often this takes place, because that amount of time, although it's a grand amount of time compared to our lives, to the life of an individual, for the life of the planet, it's nothing. It's a perspective issue.
It's a perspective. Exactly. Wow. And this is one reason why I'm an advocate for moving forward and essentially becoming a cosmic civilization. You see, I came of age during the heyday of the Mercury and Gemini and Apollo programs. And, that was the one thing when I look back and I go, you know what? One of the last times that I was really proud of my country was when we put those men on the moon, when we planted our American flag on the moon. And I really believed back in 1969, 1970 that America's destiny was to move the human species into this grander cosmic environment. And then, of course, the Vietnam War came along and other priorities, and money got shifted. The Nixon administration shifted huge amounts of money away from the space program. The timetable that was set out, that we were going to have a permanent lunar base by the end of the 70s, first manned mission to Mars before the 80s was over, perhaps independently self-supporting colonies in space by the year 2000. I remember I was a junior in high school when Kubrick's 2001: A Space Odyssey came out. Have you ever seen it?
Sure.
Yeah. 1968, nobody had any, it was no stretch of the imagination to assume that by 2001, there were going to be orbiting hotels in space, right? That could have happened, but we lost our vision, we lost our will, and we just got sidetracked. I remember in the 70s talking to people about the potential of colonizing space, using the materials and resources found in space. And the knee-jerk response I always got was, well, we've got too many problems here on Earth. We got to solve those problems first. Well, my response to that was, well, good luck, because you're basically talking about altering human nature, right? And it's going to take something more than just some policy to alter human nature. What it's going to take is some serious consciousness excursions, perhaps people going to space. Here we had these astronauts. I met Edgar Mitchell years ago. He's a Mason. He came to my lodge years ago, Edgar Mitchell, who was one of the astronauts. He was one of the many astronauts that went into space.
Mason, like as in Freemason?
As in Freemasons, yeah.
Everybody freaks out when you say Freemason.
I know.
Think Illuminati, black helicopters.
More nonsense, and we should have a whole session just to deal with that ridiculous nonsense. Next time, yeah.
Freak me out about that.
Okay.
So Edgar Mitchell, when you met him, was he talking about aliens?
No.
Aliens.
No, he was talking about going into space and seeing God.
Whoa. It's crazier than aliens.
Yeah, crazier than aliens,
Because God made aliens.
Perhaps.
So he saw God in the sense that he got a sense, without even saying God, he got a sense of the grandness of the universe.
Yes. And the potential role of humans in that.
Have you ever been to the Keck Observatory in Hawaii?
No, I haven't.
The Keck Observatory in Hawaii is a very unique place because it's on the big island of Hawaii, and it's very high up in altitude. And when you get up there, you actually drive through the clouds. I took my family there several years ago, and we were bummed out. We were like, oh, it's so cloudy. We're not going to be able to see anything. But then you pop through the clouds as you continue to drive, and the view is magnificent. And it is, to this day, one of the most intense experiences, consciousness expanding experiences I've ever had.
I believe it.
Without drugs.
Yeah.
It was like a psychedelic experience. It really was, because the amount of that's the Keck Observatory. See how it's above the clouds? That's a daytime shot. See, Jamie, see if you could pull up a nighttime shot because they set the camera aperture to capture the. I had a regular camera. I couldn't really capture the actual stars themselves. But you see the Milky Way not like that. It's way more intense than that. You see the Milky Way in its full form. You see all
right there.
Yeah, and there's so many stars. It's so shocking. You're immediately forced to accept the reality that we're in space. Whereas it's so easy to deny when all you see is the moon and a couple little dots. It's like, whatever, man. I'm in Hollywood. I got to go to work. And you drive and you get on the. That's what it's like.
Yeah,
and it's so and that's just a photograph, and that's. Obviously there's some doctoring going on because I don't know what those lines are, but it's insane how intense it is. It's insane, and it's right above you. And it's right above us all the time.
That's what I love about the high desert plateaus. You've got this dry atmosphere, and it's like literally you can almost reach out and touch the stars. We were talking about.
Yeah, you've never been to L.A. before. This is your first trip to L.A. because when you're in California, you just go to the Mojave and stare at space.
Well, I stare at space and I stare at the rocks.
Yeah.
The rocks below my feet and the stars over my head, yeah.
How did you get involved in the exploration of all this stuff?
Well, I guess it's time to come out of the closet. I think I did a little too many drugs back in the 60s.
Nah, I think you did the right amount.
Yeah.
I think you're being hard on yourself.
Actually, in 1969. So, of course, I was raised in rural Minnesota, and where we grew up, we lived on the shores of a meltwater puddle left over from the receding of the glaciers. Yeah,
call it a puddle.
I call it a puddle. It was 3/4 of a mile long. It was just Minnesota, Wisconsin's got 25,000 lakes, and every one of them is leftover meltwater puddles from the recession of the glacier. So I can still remember being like 6 or 7 years old and my dad telling me, once upon a time, this was thousands of feet under the ice. And that's how we had land on the edge of this lake. And as a kid, I used to sit in my backyard and fish for, sunfish and crappies and bullheads.
That's what I don't understand. To interrupt your story for just 1 second. How the fuck does that happen? Where 10,000 years ago, it's a glacier. 10,000 years later, there's fish in there. Where the fuck are the fish coming from?
I don't know, but they were there.
But where's the largemouth bass come from? What's with the lake trout in the Great Lakes? Where the fuck do they come from? If 10,000 years ago, that was frozen solid.
Yes, frozen solid.
Where the fuck do lake trout come from?
I'll have to get to work on that, Joe, because I don't know the answer.
I need to know, man. I'm freaking out. How about northern pike? Northern pike, you go to Saskatchewan, people fly in from all over the world to go fishing up there because they have this massive population of beautiful northern pike, these big... That was frozen.
Yes. Saskatchewan was under a mile of ice.
What the fuck, man? I'm freaking out. That doesn't even make sense.
Yeah.
So you saw this. So you were a kid.
I was a kid growing up with that landscape. So I got fascinated by it. But in 1969, I went to an outdoor rock concert that was at an airport called Eden Prairie that's in the just outside of the Twin Cities, Minneapolis. And it's on a series of bluffs that overlooks the Minnesota River Valley, right? And of course, I'm stoned out of my gourd. And I was taking a break from the music and the ladies and everything. And I went over and was standing on this bluff. And Jamie, if you would pull up, I think it's near the end of the pictures I brought for Joe, I have a beautiful example of scale invariance. And this is going to be similar to what I saw. And when you see it, that's like the 25 images that's labeled for Joe.
Yeah, which picture though?
It'll be towards the end. It's a picture of the Snake River. Find it?
Wow.
The Snake River. Wait till you see this, Joe. Now, this is an example of scale invariance. Now, what that means is that, here we go. Now, look at this. What you see here.
Where can folks that are just listening to this go and see these images? Are they on your website?
I think this one is on my website.
Okay.
Yeah, I think this one's on my website.
So the Snake River.
You see the Snake River.
Scale invariance, meaning that the river at the bottom, obviously you see the lines all around it where it indicates that there was a much, much larger body of water at one point in time.
Much bigger. The modern Snake River is about 50,000 cubic feet per second, right? At the end of the last ice age, the river here was about 30 to 40 million cubic feet per second.
So was that because of the melting glaciers, the force of the
This
river?
this particular was not directly fed by the melting glaciers. It was the result of the catastrophic overflow of Lake Bonneville, which was the result of massive, prolonged torrential rainfall that just drowned all the deserts of the western and southwestern United States. And there was an overflow, a spillway, out of the Lake Bonneville Basin in northern Utah, and it spilled over into the Snake River Plain of Idaho, 30 to 40 million cubic feet per second. Cut this channel. Now, you'll notice that the modern Snake River occupies a small channel within the big channel. That's scale invariance. The big river would have been about equivalent to 600 to 700 of the modern Snake Rivers. Wow. And what you're seeing here is an example of scale invariance. See, the little is superimposed upon this big. See, now, in 1969, I was standing on a bluff overlooking the Minnesota River Valley, similar to this, right? Looking down at the little Minnesota ribbon of the Minnesota River and seeing it in this huge channel. And I had an aha moment. And I realized, I saw then that this channel, that this bluff I was standing on had once been the bank of a gigantic river, thousands of times bigger than the modern Minnesota River. But I didn't know it rationally, in the sense that it took me another 10 or 15 years of study and research before I could go back and say, yeah, what my initial instinct, looking out and seeing this matching set of bluffs, 4 or 5 miles on the other side, and seeing this small version of it in the modern river, that I was right. That I remember one time in the 80s, I was giving a talk on that, and there was a geologist in the audience, and he got up and he goes, no. That big channel, that was millions of years it took for that channel to form. And I said, no, I don't think so. And what happened is by him challenging me, it really, I said, okay, like an MMA fighter getting challenged, says, okay, I'm going to take you on, I rose to the occasion, and I spent literally years doing research on glacial geomorphology, on paleohydrology, and of course, at the end of the thing, I knew that my instincts were absolutely correct. That yes, now there is solid, scientific, documentable, verifiable evidence that this whole channel of the Minnesota River Valley was filled brim full with water at the end of the last ice.
So when he was saying it was millions of years, he's saying that same exact channel of water had never varied, and that it had just cut through over millions and millions of years very slowly.
Yes.
But that doesn't seem rational because of the width.
No, it doesn't. You'd have to, and it doesn't. It doesn't make sense.
So this goes along with what you were talking about earlier, that the ideas of science were that everything had taken place, much like evolution, on a very gradual pace.
Exactly.
Is this the Grand Canyon as well?
No, here's what I would say about the Grand Canyon. I think that the Grand Canyon is presently, we can observe the Colorado River eroding the Grand Canyon. However, I think that the erosion of the Grand Canyon is not uniform. It's episodic, which means that the Grand Canyon has probably been there between 2 and 5 million years. Because, for one thing, the Grand Canyon wouldn't start eroding until the Colorado Plateau had lifted up. And 10 to 12 million years ago, the rim rock of the Colorado Plateau was limestones, which implies a shallow marine environment, right? Now, when it's down at sea level, it's not going to erode. It's not until the whole plateau lifts up between 5 and 10 million years ago that the downcutting can start. So my take on the Grand Canyon would be that what happens is you have to understand this now. This is I think now is the emerging paradigm. There are 2 modes of change: the gradualist mode that we've seen dominating through the last few hundred years, at least since the advent of modern science, and then if you want to call it the catastrophic mode, where as much change is compressed into a few years or months or sometimes even days or weeks, as normally would take thousands and thousands of years. When I look at the Grand Canyon, what I'm seeing there is episodes of catastrophic erosion, probably stretching back over 2.5 million years. Remember I said the Pleistocene was about 2.5 million years. What characterizes the Pleistocene from the previous Pliocene is this alternating succession of glacial and interglacial ages, this swinging back and forth between these two extremes. Those episodes of transition appear to be profoundly catastrophic, and they are associated with things like massive storms, massive rainfalls, rising and falling of sea levels on an extreme basis, and I think it's that has created the Grand Canyon. Predominantly. In fact, the inner channel, I don't know if you've ever seen Grand Canyon.
Yes.
Yeah. Okay, there's an inner gorge. I could guess that inner gorge is probably less than 100,000 years old, and probably a lot of it was cut 13,000 years ago.
Wow. And so that's when the Pleistocene ended somewhere around 10,000 years ago?
Yeah, 10 to 13,000 years ago.
Wow.
Yeah.
And that's not a real picture, is it? No, it seems like an artist rendition.
Yeah. I have pictures somewhere in there where
you get a sense.
Yeah. Now, the accumulation of the sedimentary rocks, took hundreds of millions of years. But that's one process. The downcutting, the erosion of the canyon is a different process.
So again, it comes to a matter of perspective, that we're almost incapable of, I mean, I think, academically, and you could sort of explain how all this takes place and explain what's happening, but in our minds, our perspective of living 100 years, looking back, it's very difficult to go back 20 years ago and remember when that happened? Wow, barely. But that ain't shit compared to the Earth. The Earth is just constantly changing, and our knowledge of human history, we have this sort of static view, and occasionally we have that meteor that flew over Russia recently and blew up in the sky, and everybody's like, "Whoa, what's that?" And then it stops, and then nothing. Go back to work.
Right, go back to work. Go back to sleep.
Wow.
Yeah, and that thing that blew up over Russia, that was a speck.
And there's nothing. And then there's Tunguska, which blew up in the early 1900s.
1908, June 30th, 1908.
Which just flattened thousands and thousands of acres.
Oh, well, let's see. It was 800 square miles, and there were 640 acres per square mile, so it flattened 500,000 acres.
Oh, my God.
500,000 acres. And that was, the energy of that was about equivalent to a 15 megaton bomb.
There's an image of Tunguska.
Yeah.
Just all the trees completely flattened. Except a few. Look at that gangster tree just still standing there. How's that happen?
I know, it's just like...
Every now and then, just one bad motherfucker tree. That's how people stayed alive, right?
Yeah.
Because just like everybody else died, or most things died, and most of the species died, a few people figured out a way to make it, and then they decided to have babies. What a bunch of crazy fucks. Could you imagine? Giant asteroid hits, kills everybody, rotten people, and woolly mammoths all over the place, and you're still horny. You're still horny, and you make a baby. Like, wow. And you raise it, and that baby makes more babies.
Hey, what does it say in the book of Genesis? Be fruitful and multiply. Now get this, the word replenish the earth, replenish the earth and subdue it. I think clearly that's a clear hint that's saying this is not the primordial creation, it's a subsequent creation to something, a previous order of things. Why use the word replenish? Be fruitful and multiply. It would make sense if the human population crashes in the wake of a global catastrophe and we're down hovering at the threshold of viability where, we could become extinct if just anything else happens. And we want to preserve our species. Well, probably the thing we need to be doing is having lots of sex.
That's what I'm talking about.
Yeah, exactly. I know. I mean, we need to do lots of screwing.
And we need to screw and make scientists to figure out how to get us off this rock.
Yeah. Well, see, be fruitful and multiply.
And make spaceships.
Replenish the earth and subdue it. What the hell does that mean?
Does it say subdue it?
Subdue it.
That's in Genesis?
Oh, yeah, it's in Genesis. What the hell are they talking about there?
Choke the earth.
Well, I see that's the way it's been interpreted. I think it's being interpreted to say, look, you guys are the only rational species down there. You've got these big brains. You got to be born before it takes you years and years to actually get where you can survive on your own because you got these big fucking brains. See? So we're kind of like nature's answer to all of this. Only one species right now has the ability to intercede and prevent the next global catastrophe, and that's us. Do we rise to that challenge, or do we say, well, we're going to let nature run its course, and if 50% of the species disappear, civilization is over, we go back to the Stone Age struggling for existence, well, so be it. That's what's in the cards. Or do we say, you know what? We could, within one generation, be harvesting the resources of asteroids, which we could be, if we had the will and the vision. And the thing is that the most dangerous asteroids that are out there, is the closer they get to the Earth, the more accessible they are. And you see, we already could be harvesting the resources of asteroids. I mean, asteroids are loaded with precious metals and ores and hydrocarbons. There's virtually nothing that we are now mining from the Earth that we couldn't mine from asteroids.
Wow.
What does that suggest to you? Well, and think about this. If I like to kind of imagine these scenarios. Suppose we had discovered, remember Shoemaker Levy 9?
Yes.
Okay, discovered in March of 1996. Within about 8 weeks of observations, the astronomers were able to predict that these fragmenting pieces were going to orbit the sun and come back and be crossing the orbit of Jupiter at exactly the time that Jupiter was there, right? There was going to be a T-bone collision. It was like two vehicles coming to the intersection at the same time. And they were able to predict that right down to almost to the minute, to the hemisphere. What if we discovered that there's an asteroid orbiting the sun out there that's got our number on it, and it was going to strike the Earth in 3 years or 10 years or 20 years or whatever? What would be our response to it? What would we do?
I think globally there would have to be some sort of a collective effort.
Yeah.
The scientists from China and Russia and all these different various countries that have vast technological capabilities would probably get together and have some sort of an agreement.
I would think that would have to happen. And it would probably make our petty human conflicts pale into insignificance if we were faced with the demise of our civilization or even possibly our species. But suppose we discovered it and it's coming in a couple of years, and there's no time to respond. What could we do? Well, perhaps if we had a long enough lead time, we could actually deflect. All we need to do is an asteroid that's on a collision course with the Earth. All it has to do is be nudged a little bit, and a direct hit can be a wide miss. See, that's all we would have to do is just nudge it a little. And there's various potential technologies whereby we could do that. But what if we didn't have enough lead time and we knew that it was going to slam into the Earth and for 1,000 years going to be havoc? What would we do? Well, perhaps we could go build a base on the moon or build something in space that would allow humans to survive at least until the dust settled enough that we could return and begin to replenish the Earth.
Do you know what a bummer it would be if you had a base on the moon and everyone was living there and you watched the Earth blow up?
Total bummer. But it would be even bigger bummer if you didn't have it and you were sitting on the Earth knowing that that's it, man, that's all she wrote.
How many different times do you think that this has happened while human beings are alive? And the great speculation has always been when they see the pyramids or when they see any incredible structures that we really haven't totally explained how they built. Or like Baalbek in Lebanon, how advanced were they? How advanced were they before the shit hit the fan?
Well, it seems to me that in order, you got to go, why would primitive cultures move rocks that weighed 200 to 1,000 tons, apparently with impunity? They were doing it all over the planet, right? Why would somebody be motivated? I mean, again, I'm a builder, so I know how much work it takes to move even without a crane, without modern technology, to move a beam into place that weighs a ton, right? Well, we've got stones in some of these ancient temples that weigh hundreds of tons. And again, all over the world, it seems to me difficult to imagine that they didn't have some kind of a technology that we've forgotten. What that technology is, I couldn't say. But it would sure seem to me that there would be no motive for moving, 500-ton stones unless you had some convenient way of doing it.
Or if not a convenient way of doing it, just explain how an inconvenient way they could have done it. When you get to something like the Acropolis or the Parthenon that's on the Acropolis, right? Isn't that what is the Acropolis is the stone and the Parthenon is what's on it?
The Acropolis is the hill with the whole complex on it. But the Parthenon is one of those temples.
The Acropolis is a man-made construction that has massive, massive stones that they just don't explain.
Yeah, they're there. They're in Cuzco in South America. They're in Egypt. There it is.
The Baalbek one is actually probably even more impressive, Jamie. See if you could pull that up. The stones of Baal. How do you spell it?
Baalbek.
And these stones are just unbelievably big.
Yeah.
And no explanation for how they moved them, cut them, quarried them, got them into place, and what year it was all done.
Right.
That's one vision of it or a picture of it, but if you search for others, there's actually a close-up of the actual stones themselves, and they show people standing next to the stone, so you get a perspective of it. I mean, much, much taller than a human being. In fact, I think 10 or 11 feet tall in some places. Like there's one rock, like who the fuck moved that? But some of the stones, that's not a good one, Jamie. There's some where you can see the massive amount of stone that was in each individual one. Some of them are literally building sized, and it's just an individual stone. And yeah, there's one. Like, what the fuck, man? What the fuck is that? That is so big.
Yeah.
They moved that. They cut that, quarried it, and moved it.
Yeah.
I mean, I don't know how many people they had to do that, but boy, that doesn't seem like something that a society which is really concerned with feeding itself is going to get done.
Right.
So when you see like the constructions of the Great Pyramids, which is one of the great wonders of the world, and to this day, they're always trying to come up with ways that they did it, but the sheer size, and to put it into perspective, if you cut, I think the number is 10 stones a day. There's 2,300,000 plus stones in the Great Pyramid of Giza. Mm-hmm. Yeah. And if you cut and place 10 a day, it would take you 664 years.
Yeah, having seen the Great Pyramid and many of the temples in Egypt, I'm convinced that they had to have some means that we've forgotten about for transporting these stones. They may have used fairly primitive methods to quarry the stones, but when it comes to transporting the stones, we could imagine that they're putting them on rollers and dragging them over, hill and dale. But again, you got to go, really? All over the whole planet? It's one of those things. It's like the demise of the frozen woolly mammoths. There's just no real explanation. And we can invoke explanations that are basically designed to avoid the implications of admitting that there may have been advanced knowledge, scientific knowledge in prehistory.
And that somehow or another that knowledge was lost, whether it was because of the burning of the Library of Alexandria or whether it was just a cataclysmic event that wiped out a massive amount of the population, and what was remaining was buildings like that.
Yeah.
Those things survived, and then people tried to recreate them. People eventually figured out some of the techniques and made similar structures, but not over a period of 1,000 years or 2,000 years, but maybe 20, 30,000 years.
Mm-hmm.
That's always been the work of Graham Hancock, the ideas They bounced around. And I remember there was that Charlton Heston narrated documentary on the Sphinx where they had gone into great detail about the erosion. And they brought in the geologist Robert Schoch from Boston University.
I know Robert.
Yeah. I want to get him on the podcast, too. He's a fascinating cat.
He is.
And he concluded that the temple, the Sphinx, the enclosure where it was cut out of, shows thousands of years of erosion by rainfall, which there wasn't rainfall in the Nile Valley before 9,000 years ago, so which predates the pyramid construction, the average or the conventional dating of the pyramid. There it is right there. This is some of his explanations. It predates the what the conventional date of the pyramid is by more than 5,000 years.
Oh, I'm convinced, and I've had conversations with Robert where he will basically say he's got one number for public consumption, but he's perfectly willing to admit that perhaps the Sphinx is much, much older than that. And
what's the dark number? What's the crazy number?
Oh, I think that the crazy number is tens of thousands of years. If you pull up...
It's not that crazy, though. Now... It was kind of crazy when that Charlton Heston documentary was around, but now that they found Göbekli Tepe, and they know that 14,000, 12,000 years ago, whatever it was, they were absolutely building these enormous, immense structures. That would be, 8,000 years, 7,000 years earlier than the pyramids?
Exactly.
Not that big a deal.
Not that big of a deal.
The conventional dating of the Great Pyramid of Giza is 2,500 BC, which may be correct, but it still doesn't mean that the Sphinx wasn't way, way older than that.
Way older than that, exactly. And, I'm convinced, having seen it firsthand, that erosion is water-induced. I've looked at a lot of erosion over the years, and, it's got the classic parabolic profile that you would expect if you started out with an initially square. Jamie, open up the PowerPoint show entitled Cataclysmos Global Superflood.
Cataclysmos Global Superflood. That's my new band. It's going to be my new band.
Go for it, man.
Cataclysmos.
Cataclysmos was the Greek term for the destruction of the world by water.
Oh, wow.
It's from where we get our term cataclysm.
Whoa.
And their term, the Greeks believed that there were alternating destructions of the world by water and fire, right? Ekperosis was the Greek term for the destruction of the world by fire.
Wow.
And cataclysmos of water.
This stuff is so unbelievably fascinating because there's no way that you can attribute all of this stuff. I mean, all of these ancient structures, there's no way you can attribute it to what we know about their culture. We don't know enough. There's just not enough evidence. There's not enough. We don't know enough about ancient Egypt or their construction methods. There's so much thinking. There's so much guesswork. So much. When you look at these giant structures and you wonder, what were they doing? How did they do this? Who were they like? It's so fascinating. I would love to be able to go back in time as a giant bulletproof bubble.
I know.
And just hover over ancient Egypt.
Yeah.
What was going on back then?
I know.
What did you guys know?
Jamie, you've got Global Superflood.
What is this image?
Go to slide 58.
Slide 58. The infamous slide 58. Hanger 18 and slide 58.
There it is.
Wow,
All right.
That's beautiful.
Okay.
That's amazing.
Now, what you can see there is
you got to get it at the microphone. Get on the microphone there.
The Valley
you can
Temple.
see, look up there.
Oh, yeah, okay. The Valley Temple with stones quarried from the ditch around the Sphinx. You got to remember what the Sphinx is, that originally it was a yardang, which is a limestone outcrop that sticks above the surrounding landscape. The yardang was the head of the Sphinx. Everything else was below. Now go to the next slide, Jamie. Okay, there you can really see the ditch surrounding the Sphinx, and the layers forming the Sphinx body correspond to the layers in the surrounding ditch. Now, to me, you'll notice the scaffolding next to the Sphinx. They're undertaking these campaigns of quote unquote restoration
It's gross.
But what they're actually doing is they're covering up the real message of the Sphinx.
Yeah, why are they doing that? Why are they bothering to try to rebuild the thing?
I
Because
don't know.
It's so stupid. Like, wait, you're not rebuilding it. You're building new shit.
Yeah, you're just refacing it with
Yeah.
with new stone.
It's so gross.
But at least nobody is messing with the quarry walls where you can see the water erosion so effectively displayed. Go to the next slide, Jamie. Now, what we see here is an abandoned quarry. It's hard to tell the scale here because that opening is like 40 feet high. But if you look at, you see the striations in the rock wall? Okay, this is where they quarried the blocks, right, and removed the blocks. Go to the next slide, Jamie. Okay, this kind of shows the methodology that they used. They would create these separation trenches. They would usually go by the natural bedding layers of the rock. Go to the next slide, and you'll see here's the presumed process where they're cutting a separation trench, and there's a block about to be quarried there, and then you can see there would have been a stack of 4 blocks there.
And these blocks are enormous, several tons.
Oh, yeah, that block there would be, looks like it's probably about 4 by 8 by probably 10, so like 320 cubic feet at 160 per, so or 180. So you're looking at about 57,000 pounds divided by 2,000. So yeah, about 30 tons.
Jesus
About
Christ.
30 tons for that rock right there. Now go to the next slide.
30 tons.
Okay, now, the reason I'm showing you this is because this is the process they would have used to quarry the blocks away from the surrounding the Sphinx and exposed a quarry wall. Well, at the time that quarry wall was exposed, it would have been essentially a flat surface with this slightly stepped profile like we saw in the photograph, right? Now go to the next slide. Right, so there's now would be a cross-section with all of the blocks removed. Okay, go to the next slide. And what we have here is stone pick marks in a limestone, quarry from Ramesses times, about 1200 BC, so about 3,200 years ago. So here's a limestone face of a quarry that's been exposed for 3,200 years.
And it seems like they used some sort of a chisel to get that out.
Exactly. The pick marks are still visible. Go to the next slide. Okay, here's stone pick marks in a quarry from the early New Kingdom, circa 15. So 3,500 years ago, you can actually determine the type of tool that they used to quarry the rocks, the picks or the chisels. Go to the next one.
Based on the marks that are on the rocks.
Based on the marks,
itself.
yeah. And here you see that the chisel marks made, or pick marks made by stone picks in an Old Kingdom limestone quarry, 2,000 years BC. So here's a 4,000-year-old quarry that's been sitting exposed to the desert elements, and the pick marks are still visible on the face. Now go to the next slide. Now here's the Sphinx. Go to the next slide, and look at that quarry wall.
Yeah, that's crazy.
It's crazy. Yeah.
That-
Now, supposedly, this quarry wall is only a few centuries older than that last picture we just saw where we could see the pick marks. Does that make sense?
Well, the only way it would make sense is if there was a vastly different type of stone.
Well, it's not, though. It's the same. It's a well-indurated limestone. Robert can tell you all about the composition of that stone.
But the composition does vary, though. Am I
yeah.
correct? Like some of it's more dense than others, and that's
You can see-
indicative of the changes.
Yeah, and you can see that indented layer about halfway up is going to be a softer limestone. Absolutely.
It certainly looks to the layman, and I'm clearly a layman, but it certainly looks like water fissures, like fissures that are from rainfall.
Even to the trained eye, it looks like water.
But some legit Egyptologists and even legit geologists have tried to attribute this to wind and sand.
Well, again, Robert has shown pictures of the comparison of wind erosion to sand erosion or water erosion, and they don't look the same.
So the only reason to attribute this to wind and sand, it's not based on the scientific evidence of what it looks like when there's water erosion. It's to confirm or to conform with the known or established timeline of construction.
Yes, and that's why I showed you those examples of other quarry, like that Old Kingdom quarry that's almost the same age as this.
So it's actually really not scientific to try to attribute it to wind and sand. It's just what you're doing is confirming to confirmation bias. You have an idea in your head, and you're trying to make this really odd erosion fit into that. But that doesn't look like wind and sand.
No. Go to the next slide,
smooth
Jeremy.
and liquid.
Joey.
Jamie.
I'll
Call him Jam Band. That's what everybody calls him around here.
Okay. So there's the depth of the ditch. It's about 22 feet, and there it shows each of the layers. Like if you look at layer 11, that's going to be a softer limestone. It's eroded deeper.
Right.
Now go to the next slide, and you'll see what I've done is superimposed what the original profile would have looked like. And there's been an enormous amount of rock, limestone rock, removed. And we know the profile would have looked like that because the stones that were quarried are what make up the Sphinx and Valley temples.
Right. And those have been eroded as well, but unfortunately they've covered that up with this reconstruction.
Well, most likely, and I think Robert would confirm this, that the limestone blocks that formed those temples were sheathed in hard granite. Whereas this quarry wall was not. It was exposed.
Well, then there's also the issue of the Sphinx head itself, which seems to have been altered. And this is a timeline thing that folks may or may not know, but there's been Egypt changed quite a bit. I mean, ancient Egypt was around for thousands and thousands of years, and at some point they were conquered by the Nubians. And the more African, what we think of as traditional African face, obviously Egypt is a part of Africa, but the more traditional looking African faces is what you see in the current face in the Temple of the Sphinx. So probably what had happened is a later date pharaoh said, you know what, fuck this lion, I want my face up there. So they put the face of this.
Probably Kefren. And I think both John Anthony West and Robert Schock would concur with that.
That's why there's so little erosion on that face.
Right.
Because that face is only a few thousand years old.
And why it would be disproportionately small compared to the rest of the body.
Wow, it's so fascinating. I would give so much to know what they knew then. At any point in time to go back in human history and just to be able to observe, that would be the time. Just the middle of Egypt. I would love to see what it looked like before they raided it and took off. For folks who don't know, it was covered in smooth limestone, and they cut it all up to build Cairo. They raided it.
Yeah, there was an earthquake that flattened Cairo, and they had attempted to penetrate the Great Pyramid prior to that without success. But apparently the earthquake, which I think it happened in the 12th century, loosened a few rocks from near the top of the pyramid that allowed them to get some levers in there and begin to pry them loose. So I've read...
What a bunch of fucking assholes.
Talk about vandalism. Now get this. Whether this is true or not, we have no way of knowing. But there are many, many Arabic accounts and counts of early travelers, and pretty much they all unanimously declare that the entire outside of the pyramid was inscribed. Whoa. Now think about that. What in the hell would that have been telling? What kind of message was that was being sent to the future?
That must have been amazing.
Yeah, I get my hair stands up on my legs just thinking about it.
Inscribed.
Yeah.
Hey, listen, there's rocks in space, and occasionally they land, and when they do, you're fucked. Build one of these. Get inside. Wait for further instruction. It's amazing that they're still there. I mean, if that thing existed, if Robert Schock is corrected, and that thing existed before the Holocene events, that those are the only types of structures that would still be here.
Yeah, exactly.
How the fuck did people make it through there? I wonder what the number was.
Well, I'm going to tell you.
The Adam and Eve story.
Here's my theory on it. All over the world, we have traditions about catastrophes and cataclysms and giant floods. All over the world, they've come down to us. And there's a lot of deviation, but there's also a lot of similarity in them. The idea that a small group had some kind of foreknowledge, whether it was Noah in the Bible or Deucalion in the Greek myths or Utnapishtim in the Sumerian myths or Xisthus or Manu. I mean, the culture heroes that survived these great cataclysmic floods are in the dozens and dozens, right? American Indians had prolific traditions about giant floods. When George Catlin, the famous Indian artist, spent decades of his life going around living with various Indian tribes, like 40 years painting and writing about them. Very interesting quote in one of his books. He says that they were widely divergent with traditions and language and customs and so on, but of 120 tribes that he visited, they all had one thing in common, that they were descended from survivors of some gigantic cataclysmic event. That's American Indians. You find it in North America, you find it in South America, you find it in the Polynesian Islands, you find it in Australia, Japan. I mean, it's around the entire planet, this idea. And now modern science is confirming what we assumed was merely some kind of superstitious nonsense of, pre-scientific illiterate barbarians. And we're realizing that those myths and those stories and epic tales that have been handed down for centuries and centuries actually contain hard scientific truth from surviving eyewitnesses.
Well, if these craters actually do exist, and they do, right? The
they do.
Holocene crater is undeniable. The nuclear glass throughout Asia and Europe, undeniable. Human beings were alive then.
Yes.
And if human beings were alive then, they got fucked up. There's no doubt about it.
Yeah, they did. They would have suffered enormously. And just like, if 3/4 of the species of animals in North America went extinct, do you think that the 25% surviving came through completely unscathed? No, it simply means that there's a threshold above which a species is viable. It can survive. And below which, there may have been survivors, but there just weren't enough of them. They were too widely scattered, serious habitat loss, which would have diminished food supply, and they just died out. But either directly or indirectly as a result of these catastrophic environmental changes that accompanied the ending of the Ice Age. Humans had to have been affected by this. And all of the myths and the stories would totally concur with that idea, that there were humans. And they're all consistent with this one detail, that there were some humans that had foreknowledge. And so they built arks. Deucalion built an ark, just like Noah did. Utnapishtim built an ark. Xisithras built an ark. Manu built an ark. Where are these stories coming from? Are they just completely conjured up independently of one another and that detail is just thrown in? Or is there some kind of a reality behind this, that there were people who had foreknowledge? Well, if there were people that had foreknowledge, it suggests to me that there were two groups of survivors. Those who survived because they intentionally planned to survive. They had foreknowledge. They took steps to secure their survival. In Freemasonry, there's the account of Lamech or the account of Enoch. There's variants on it. But Enoch, the story of Enoch in Masonic tradition says that Enoch had, he was in the patriarchs before Noah, had this foreknowledge that the world was going to be destroyed either by fire or flood. So he created this underground vault. It was deep underground, and it was preserved within 9 layers of stone. It was 9-layered vault. And you only, unless you had the key to accessing to how to access this vault, which was now like a time capsule that preserved the science and the knowledge and the wisdom of the pre-diluvian world or pre-flood world. He then set up 2 pillars, a pillar of brass and a pillar of marble. The pillar of brass designed to withstand the effects of the cataclysm, the watery destruction. The pillar of marble, if I'm remembering it right, was to withstand the destruction by fire. So there were these 2 pillars that basically informed any survivors that there was this 9-chambered underground vault that contained the secrets of the previous world age that was coming to a pass. And that's an intrinsic part of Masonic tradition. In fact, the whole Masonic symbolism is based around that idea. And it has parallels throughout other traditions as well. Well, what I'm getting at here is if there was some people who had foreknowledge of it and took steps to survive, they were the ones who preserved the knowledge of the previous antediluvian world order. The other survivors just survived by the luck of the draw, like that tree standing there. right? They just happened to be in the right place at the right time. They survived. But now they are going to be the ones who are going to be wholly preoccupied simply with the task of surviving, finding enough food to eat and shelter, because clearly the planetary environment was going through all kinds of changes, whereas the other group had taken actual steps to survive and preserve knowledge. Now, when we look at the beginning of recorded history, 4,000 to 5,000 years ago, we're basically halfway back through the Holocene, right? Okay, let's, for purposes of conjecture, assume that at the end of the Holocene, human population crashed, right? Well, if you want to build a pyramid or a great temple, you've got to have a labor force, right? Well, if you've got scattered bands of survivors, you basically aren't going to be able to accomplish that. Now, let's assume that you've got two groups of humanity, one that's sitting there with all of this knowledge at their disposal. Just like, imagine it if our modern society was wiped off the face of the earth, but somebody somewhere in some deep cave underground was able to preserve our knowledge of physics and chemistry and the various sciences. Well, obviously, in order to run this computer that we're running here, to do this broadcast requires an huge intact infrastructure, right? Well, we could know how to build a computer. We could know how to broadcast, but if we don't have the infrastructure, we're just sitting on information, right? Well, let's assume that you have a group that survived, right? And they're the custodians of this body of knowledge, right? Now it takes 3,000, 4,000, 5,000 years for the human population to reconstitute itself, and now you've got a labor force. And let's suppose that there's going to be another cataclysm impending, such as the one that perhaps caused the Noah's flood, which, there's evidence now that around 5,000 years ago, there was an asteroid impact into the Indian Ocean, right, that plunged through 2 miles of ocean water and blasted a 12-mile wide hole on the floor of the Indian Ocean.
And what year was this?
This would have been about 5,000 years ago.
And how much of an impact would that have had?
Oh, it would have created tsunamis. Well, on the island of Madagascar, on the southern island of Madagascar, and it should be in this program that we've got open right here, Jamie. If you go to slide number 111.
It's so ironic that today our focus is closer and closer to the cloud, closer and closer to chips, to solid state hard drives, all these different things that are just not going to last.
Right.
No paper, but no one's carving anything in stone. All the knowledge that we have is like how much of what everybody has is on hard drives. I mean, how much of what everybody has is in the cloud on a server somewhere.
Yeah.
And who the fuck is going to be able to figure out how to read that shit 1,000 years from now?
Yeah,
if anything happened to us.
Yeah, just like we're trying to figure out how to read Egyptian hieroglyphs. Yeah. Okay, look at slide number 111. Now, wish I had my pointer here. Go to the next slide so you can see right there. You see those wiggly things?
Looks like dragon scales.
Yeah. What that is it's water, ocean water that washed on land and washed up, and you see it kind of comes to a point, and then it washed back out. This is a tsunami deposit. And those features that you're looking at, they kind of look like this. They're called chevrons, right? That's what happens when the water washes in, makes deposits of giant ripples, and then washes back out.
What kind of time frame are you talking about when this happens? How long does it take to do that?
Oh, hours.
So that all happened in hours?
In hours, yeah.
And you could still see it today?
Oh, yeah. Go to the next slide, Jamie. We're getting a closer up look here. Now, you see how they're shaped almost V-like? Mm-hmm. That's the chevron, like a sergeant stripe almost.
Right.
Okay, go to the next slide. Okay, here's a cross-section of one of those V-shaped hills. It's 600 feet in height.
Wow, that's incredible.
Now, what
you're seeing back that up one more, Jamie. So those images right there, what we're seeing there, it looks like the effects of a river or water or something.
It is water, yes.
But then when you go back, you see it from the ground, it looks like hills.
Yeah, 600 feet high.
So you're talking about a massive amount of water.
We're talking about a tsunami whose minimum run-up height is the thickness of these hills.
600 feet.
Minimum.
And that's, of course, massive amount of weight and devastation. And this was all 5,000 years ago?
Yeah, go to the next slide, Jamie. There's Madagascar, location of the chevrons on the southern edge of Madagascar. Let's see, go 2 slides up. And over on the other side, at the same age, if we look at the southwestern coast of Australia, I think the next slide will get a closer in view. There we go. You see that splooge? Mm-hmm. That's the technical scientific term.
Is it really?
Splooge? No, I just made that up. But you see the stuff that's been washed over? You can see it. It's very clear there. Okay.
Yes.
That's the other side of the ocean.
So the other side of the ocean, directly opposite of where this thing impacted.
Yeah. Go to the next.
Massive impact in the middle.
Yeah.
Ancient crash, epic wave.
Let's go back to that slide where it says ancient crash, epic wave. Next slide. Keep going.
Right there.
Right there. Can we read that?
Yeah, at the southern end of Madagascar lie 4 enormous wedge-shaped deposits called chevrons that are composed of material from the ocean floor. Each covers twice the area of Manhattan, with sediment as deep as the Chrysler Building is high. On close inspection, the chevron deposits contain deep ocean microfossils that are fused with a medley of metals typically formed by cosmic impacts. Wow, holy shit.
Yeah.
Holy shit.
And
so that if that happened 4,800 years ago, what kind of an impact would that have had on human civilization?
Oh, well,
worldwide?
It pretty much would have wiped out anything adjacent to the Indian Ocean.
Anything close to it, but what about on the other side of the planet? I mean, there would have to be some massive effects.
Oh, there would be. Most likely what we would see on the other side of the planet is extreme weather events. Hurricanes, torrential rainfalls, things like that, winds.
Kill a huge amount of people worldwide.
Could kill a huge amount of people worldwide, yes.
Wow. And so that is probably the most recent one.
That's probably the most recent one.
God. And no record of it because people really didn't have many records.
Well, I think the record of it
ago.
is probably when we see these stories like Noah's flood and the rest.
So that's probably about this one. So it's not even about the Holocene one. It's
Correct.
about one 5,000 years after the Holocene one.
Yes. See, that's what we're beginning to realize now is that these events have happened with a much greater degree of frequency than anybody had imagined.
Well, congratulations. You freaked me the fuck out. I just want to say, you had an objective and you pulled it off. 5 stars, A+ freak out. Wow. This has been an intense 3 hours. It just flew by.
3 hours?
Yeah, we just did 3 hours.
Wow.
It's over. Yeah. Isn't that amazing?
Yeah.
We got to do this again. I bet you could talk for another 16 hours.
Yeah, I mean, we've barely scratched the surface here.
Oh, please, let's do it again. Let's take a couple months off, regroup, and come back in again.
Oh, I'd love to.
We'll do some more. Please. Thank you very much for doing this. I really, really appreciate it. It's incredibly enjoyable, incredibly enlightening for me. I really, really appreciate it. I knew it was going to be like this, just the brief conversation that we had a chance to have in Atlanta, many years ago. I've been looking forward to talking to you again. Thank you very much for doing this.
Oh, it's been awesome. I really, really have enjoyed it.
If people want to research more of your work, read more of your stuff, where can they go? What can they find?
Go to sacredgeometryinternational.com, and there are links there. I've got another website that's linked from there. So in Sacred Geometry International, I deal with a bunch of different stuff, not directly connected necessarily with what we're talking about here, but there will be links to another website that I've got where I'm really exploring like the catastrophic stuff, where I've got lots of images of things. Because I've done lots and lots of field exploration, and I have thousands of images of just awesome stuff.
Does sacred geometry have anything to do with this stuff, or is that a totally different
Sacred
subject?
geometry, put it this way, as we've inherited this corpus of ancient knowledge, sacred geometry is one of the keys for deciphering these ancient traditions, because all of these ancient temple structures, which are the textbooks in stone, if you will, have several components in common, astronomical and geometrical being the two predominant. And if you understand the geometry, you realize the geometry is like a universal code whereby you can preserve certain types of information because geometry is universal. It doesn't matter what your spoken language is. The principles of geometry are what they are. You know, the relationship of a radius to a circle is the same, and it doesn't matter what culture you come from, you see. And so geometry is a critical means of deciphering the knowledge that, and I think that the predominant way of preserving ancient knowledge is in the temple structures. And they have to be looked at as textbooks in stone. And once we begin to realize that, then we can go, it's like when you go to Egypt, it's not just the hieroglyphs, that's a part of it, but it's also the geometry and the astronomy that's encoded there. And we can see the same astronomy at work whether we're looking in Egypt, whether in geometry, or whether we're looking at megalithic structures in ancient England, or whether we're looking at monumental earthworks up in the Ohio Valley, or we're looking at the mine. You've been to Chichen Itza, right?
Yeah.
Okay. That whole complex there is laid out according to principles of sacred geometry and astronomy. And it's exactly the same principles underlying that as we find in Egypt.
That will be our next conversation.
Oh, it'd be a great conversation.
Oh, I can't wait. I can't wait. Thank you so much. Really appreciate it. Randall Carlson, ladies and gentlemen. You can follow him on Twitter. It's Sacred Geo INT for Sacred Geometry International. Is that what it is? Mm-hmm. So Sacred Geo INT on Twitter, and sacredgeometryinternational.com is the website. Thank you so much, man. Really amazing, and I can't wait to talk to you again. I'm gonna start going over your material on your website and gear up to for our next conversation, man. Just amazing stuff. Thanks to our sponsors. Thanks to onit.com. Go to ONNIT. Use the code word Rogan and save 10% off any and all supplements. And thanks also to NatureBox, the official snack provider of the Joe Rogan Experience. Go to naturebox.com/Rogan to save 50% off your first box. That's naturebox.com/Rogan. We'll be back tomorrow with Dr. Rhonda Patrick returns. And until then, go fuck yourselves. How about that? I don't mean it. I love you. Big kiss. See you soon. Mwah.